Hello there and welcome back to the Sleep Science. Tonight, your eyes wander through a velvet black sky that seems to hum with static. There's the faint smell of coal dust from an open window, the soft click of your old desk fan wobbling at its base. You've been scrolling through astronomy forums for hours, half asleep, half hypnotized by thumbnails of distant galaxies, when you see it. One tiny new post buried among the noise. Uncatalogued comet. Possible interstellar origin. The thread is only 6 minutes old. You squint, brightness turned low, blue light pooling over your blanket. There's a grainy photo, just a blurred smudge, but somehow it catches you. The caption reads, 3I/ATLAS, preliminary observation. The tag 3I alone makes your heart skip, because that means third interstellar. Only 2 others have ever been confirmed, Oumuamua in 2017 and Borisov in 2019. And both, you remember, left astronomers arguing for years about what they really were. You think about how Oumuamua's odd acceleration still hasn't been explained, and how Borisov looked almost disappointingly normal. Maybe this new one will finally behave like it should. But deep down, you know nothing that drifts in from another star system ever really behaves. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your location and the local time in the comments. I want to know who's awake with me right now, staring at the same cosmic darkness. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The photo loads slowly, each pixel painting a colder universe. You zoom in until the noise dances. The comet, if that's what it is, sits halfway between the constellations Lynx and Camelopardalis, in a region astronomers jokingly call the celestial nowhere. It isn't supposed to glow this early. Most comets only brighten near the sun. Yet here it gleams faintly even at 6 astronomical units out, nearly twice as far as Jupiter. That shouldn't happen, not unless something inside it is waking up. You picture the Atlas telescope array in Hawaii that first spotted it. Massive domes perched on volcanic rock, breathing fog in the dawn air. Operators sipping cold coffee, watching the live feed stutter while an algorithm flags the object's motion as anomaly, unclassified. One technician probably laughed, muttering something about another false positive, but the track didn't vanish. Frame after frame, the speck crept across the CCD sensor, steady and stubborn. You drag your cursor over the coordinates again. The numbers look right, but your gut says wrong. You cross-check with NASA's Minor Planet Center database, and there it is. Provisional designation 3I/2025A3, Atlas. Newly confirmed third known interstellar object. Somewhere in the comments someone jokes, "We really need a bigger welcome mat." Another user replies, "We need a bunker." You chuckle quietly. Third interstellar visitor and already humanity has run out of chill. But still, you can't shake the feeling that this one's different. The initial velocity is too high, yes, yet the curve of its entry seems soft, not ballistic. As if it approached the solar system sideways, skimming the ecliptic plane like a surfer catching a wave. Historians of astronomy would tell you that every age has its celestial omen. The Great Comet of 1811 coinciding with Napoleon's campaign, Halley's Comet spooking medieval Europe. Even the Aztecs recorded a smoking star before Cortez arrived. You smile at the thought that maybe, thousands of years from now, someone will find your screenshot and say, "This was the night it began." The next morning you wake to a storm of headlines. Third interstellar object confirmed. Comet or alien artifact. The mainstream outlets love that last one. You scroll past the clickbait until you find the real data. Apparent magnitude 17.8, relative speed 58 km per second, eccentricity 1.034, definitely unbound. The numbers whisper, "Not from here." And yet, something about the brightness curve makes astronomers frown. It fluctuates rhythmically, almost like a heartbeat. You sip yesterday's coffee and open the raw light curve plot. The peaks repeat every 47 minutes. You jot it down because patterns mean rotation, and rotation means clues about shape. But when you run the numbers, the implied density doesn't make sense. Too low for rock, too stable for rubble. You wonder if the nucleus is hollow. Later that week, the first full-colour composite arrives from a Chilean observatory. Against the infinite black, 3I/ATLAS glows pale turquoise, a shade between seafoam and ghostlight. You find out that the hue comes from cyanogen gas, a poison once used in mining and darkly enough in warfare. The irony isn't lost on you. Space throws us something deadly, and we call it beautiful. A historian friend messages you, half joking, "Remember that crocodile dung sunscreen Egyptians used? They thought it kept Ra from burning them. Guess ancient protection rituals are trending again." You laugh, but the comparison sticks. Humanity's old superstition is never far from its new science. Night after night you check the orbital updates. Each time the parameters shift slightly, like the universe itself can't pin the thing down. Some comment threads claim gravitational interference from Jupiter, others whisper about an unseen planet pulling the strings. Historians still argue whether 19th century astronomers truly believed in Vulcan, that imaginary world once thought to orbit inside Mercury's path. Maybe 3I/ATLAS will be our new Vulcan, a mystery patched with math until the math collapses. You start seeing patterns everywhere, in the power line hum, in the flicker of the Wi-Fi router, even in the way your cat stares at empty corners. Sleep deprivation, you tell yourself. Still, every time you blink, you see the comet's faint trail etched against your eyelids. By the second week, amateur astronomers flood YouTube with telescope footage. Some clips show the coma, the misty halo, flaring for just a second, as if reflecting a strobe of invisible light. In one frame, a faint ring appears, like ripples from a dropped stone. The comments explode with theories: internal outgassing, magnetic interference, alien disco ball. You bookmark them all. One evening you join a live stream from the Pan-STARRS team. The host explains that the comet's path appears slightly retrograde, meaning it's moving opposite the planet's direction. He compares it to a salmon swimming upstream, except this fish weighs billions of tons and is on fire. The chat scrolls faster than the stars themselves, full of emojis and nervous laughter. You type a single question. Could it be controlled? But it vanishes under the torrent before anyone answers. Later, when the stream ends, you step outside. The city lights drown most constellations, but you find a patch of honest dark near the park. The air tastes metallic, like upcoming rain. Somewhere above, that turquoise spark is sailing through space at 58 kilometers per second, carrying dust older than the sun, maybe older than fear itself. You raise your phone camera just in case. The photo shows nothing but noise. Still, you keep it. You'll call it proof of curiosity. Inside again, you check the updated orbit diagram. The object's incoming vector traces back toward the constellation Lyra. That's interesting, because Lyra houses Vega, one of the brightest stars in the home system Carl Sagan once imagined aliens might come from in contact. Coincidence, obviously, but your sleepy mind clings to it. Maybe all stories end up looping through the same stars. At 2 a.m, an astronomer on social media posts a curious observation. Thermal readings show 3I/ATLAS, maintaining constant temperature despite distance variance. That shouldn't happen either. Comets usually cool as they recede or warm as they approach. This one stays stable, like something managing its own thermostat. You whisper to the empty room, "That's not natural." The fan answers with its low, loyal hum. You remember that time in 1995 when Shoemaker-Levy 9 broke apart before hitting Jupiter. How the world watched those impact scars spread across the gas giant's clouds. That event changed planetary science forever, proving that catastrophic collisions still happen. Maybe 3I/ATLAS is just another celestial accident waiting to happen. But deep inside, a thought drifts like space dust. What if it's not an accident coming toward us, but a message passing through? By morning, your inbox holds a short reply from an observatory contact. The subject line simply reads, "Not from our backyard." Attached is an image sharper than any yet released, 6 long exposures stacked. You can almost feel the telescope's mirror trembling through the pixels. The comet's tail looks uneven, kinked, as though twisted by some internal machinery. You blink, zoom in, and see a faint symmetrical edge within the blur. Artificial, probably artifacting, you tell yourself. But the word artifact lingers there, half pun, half prophecy. You lean back, rubbing tired eyes. The world outside is waking, unaware that somewhere past Jupiter, a visitor without a home is gliding toward the warmth of our star. You try to imagine its silence, the vacuum hiss replaced by nothing at all. A speck of alien ice threading through magnetic fields, unseen except for those few who stare too long. You feel suddenly small but oddly privileged, as if you've been allowed to peek behind the universe's curtain. Your coffee's gone cold again. You save the new photo to a folder labelled a TLAS_collection and close the laptop. But the reflection in the screen shows your own eyes glowing faintly with that same ghost blue tint, and you laugh under your breath. Great, you murmur. Now I'm projecting cyanogen vibes. The joke lands softer than you expect, lost in the hum of the fan. Outside, dawn edges over the horizon, pale and slow. You glance once more at the coordinates scribbled on a notepad, your personal invitation to a cosmic mystery that has only just begun. The next evening, you're still thinking about that turquoise smear threading through the darkness. Your laptop's fan has become the rhythm of your nights, a metronome for curiosity. Every refresh of the astronomy forums brings new data, new conspiracy threads, and the same anxious energy pulsing behind every comment. Where did it come from? The official bulletins keep repeating the phrase hyperbolic trajectory, but the diagrams never quite line up. You study them like tarot cards, tracing the bright lines looping in and out of the sun's influence. 3. I/ATLAS doesn't behave like a tourist. It glides through gravitational wells with the smooth precision of something that understands them. Each simulation you run collapses into chaos unless you add one peculiar variable, a faint, consistent push that isn't accounted for by solar radiation or outgassing. It's as if some invisible hand were guiding the object, making minute corrections as it travels. The chat rooms buzz with new guesses every hour. Maybe it's an interstellar iceberg, maybe a remnant from the explosion of a distant star. You find one wild post claiming it's a chunk of the first planet to orbit a black hole. You roll your eyes but can't help reading the whole thread. You've learned that even the most ridiculous theory can hide one accidental truth. Historians of astronomy remind everyone that discovery often starts as blasphemy. They love retelling how in 1543, Copernicus dared to suggest that the Earth wasn't the universe's centre, and how he waited to publish until the very year he died. You imagine him staring at a candlelit manuscript whispering, "They'll call me mad." Maybe every generation has its own Copernicus, squinting into the void and wondering if they're glimpsing heresy or history. You check the live orbit tracker again. The coordinates update with a twitch. For the first time since its detection, 3I/ATLAS's predicted route shifts toward the plane of the planets. That shouldn't happen unless something perturbed it, something big. Maybe Jupiter's gravity, maybe something else. The official data page stays silent, as though the universe itself needs time to decide whether the motion is real. You pour another cup of coffee. It tastes like burnt rubber, but it keeps you awake. The clock reads 1:44 a.m. Somewhere between the seconds, you start to feel that odd, crawling sensation of being watched. Not by eyes exactly, but by probability itself. The following day, a press briefing airs. A tired NASA representative with the resigned tone of someone who hasn't slept all week says, "We have verified the interstellar origin of 3I/ATLAS. It is not gravitationally bound to the Sun." He smiles too tightly. You pause the video and replay the sentence 3 times. Not gravitationally bound means it will leave again, eventually, unless something convinces it to stay. You open the comment section beneath the stream. Someone named Deep Sky Dan posts a curious observation. The trajectory doesn't trace back toward any known stellar nursery. That's strange because most interstellar objects we expect would be flung out of young, chaotic systems where planets are still forming. Instead, 3I/ATLAS seems to have originated from a void between constellations, a place that technically belongs to no star, a visitor without a home. You remember that medieval sailors once feared the ocean's edge, where maps simply stopped. The Latin phrase hic sunt dracones, here be dragons, was scrawled across the unknown. Maybe cosmic cartographers need a new version, hic sunt cometae. When the first radar ping returns from the Deep Space Network, the scientists cheer for a moment before the graphs turn puzzling. The signal bounce looks smeared, as if the object's surface absorbs and re-emits at staggered intervals. Like sonar off a jellyfish, one engineer tweets before deleting the post an hour later. You screenshot it anyway. The weirdness only deepens when the University of Arizona releases infrared data. The heat signature isn't round or elongated, it's polygonal, 8-sided. You imagine a snowflake carved by engineers instead of nature. each facet aligned to capture sunlight at specific angles. You tell yourself geometry happens in nature all the time. Beehives, crystals, Saturn's hexagonal storm. But that argument feels increasingly desperate. Later that night, you join a live stream hosted by an amateur named Mireia from Argentina. Her telescope feed shows the comet as a faint smear, barely more than static. Yet there's something hypnotic about her commentary. Soft Spanish vowels drifting through static like lullabies wrapped in science. "Está vivo," she murmurs once, forgetting she's unmuted. "It's alive." You don't laugh this time. Historians still argue whether Giordano Bruno truly believed the stars were suns with their own worlds, or if that was a poetic metaphor that cost him his life. Either way, you think he would have loved this era, where telescopes can confirm what once burned philosophers at the stake. Somewhere in the back of your mind, a small, reckless part of you hopes 3i/ATLAS is alive, because then at least we'd finally have company. 3 nights later, the European Space Agency releases its refined trajectory. For the first time, there's a tiny but measurable drift. Not random, not caused by pressure from solar radiation. It's lateral, as if the comet corrected course by about half a degree. Statistically meaningless, the report insists. Emotionally, devastating. You find yourself whispering numbers into your phone's recorder. Distances, velocities, timestamps, like you're dictating a confession no one will ever read. Outside, the city hums with indifference. Inside, the space between heartbeats sounds suspiciously like waiting. Your friends have started calling it your space phase. You try to explain the beauty of uncertainty, how rare it is to witness science being born in real time. But they only hear obsession. Maybe they're right. When you close your eyes, you no longer see darkness. You see orbital diagrams and faint turquoise trails looping like neon ghosts. A week later, the Hubble photographs arrive. You almost drop your phone. The image isn't sharp enough to show detail, but it reveals a coma that's strangely symmetrical. 2 opposing jets instead of 1. Comets usually vent gas chaotically. This one breathes evenly, like a creature with lungs. One article jokes that 3i/ATLAS might be the most polite comet in the universe. You laugh once, softly, because jokes are how humans hold hands with fear. That night, under the hum of your desk lamp, you scroll through old astronomical sketches. In one 18th century journal, an artist recorded a 3-lobed star, visible for one night only, then gone. The drawing looks eerily similar to 3i/ATLAS's current profile. You trace the ink lines with your finger. Maybe that long-forgotten astronomer saw the same traveller during a previous pass, 6 centuries ago, before it fled beyond Pluto. The dates almost match if you stretch probability. You whisper, "Welcome back." Your dreams grow vivid. You're standing on a frozen plain under a sky that won't stop moving. Above you, the comet hangs so low you can hear it, a sound like deep wind across glass. Every blink feels like a century. You wake up drenched, heart drumming like data packets. The next morning, an independent researcher posts that 3i/ATLAS's composition includes metals that shouldn't coexist, nickel-iron with embedded silicate patterns. The ratios don't match any meteorite ever recovered. The skeptic in you screams about calibration errors. The believer just smiles and whispers, "Or blueprints." Across social media, theories bloom like frost. Some claim it's a derelict alien craft. Others call it a probe seeded by a long-dead civilization. A few point to old Sumerian myths about icy messengers sent from the gods. One even insists that the ancient phrase Ninjaba's star describes the same trajectory. Historians still argue whether that myth referred to Venus or something stranger. You save the thread anyway. Myth has a way of becoming science when time stretches long enough. Your inbox pings. It's a message from Mireia, the Argentinian live streamer. She writes only, "Check coordinates 12 hours 38 minutes 9 seconds plus 44 degrees 52 minutes. You punch them into the database. It's an updated position, slightly off the predicted path, almost as if the comet slowed down. That's impossible without a thrust. Unless. You sit back, exhale slowly, and glance at the ceiling like the answer might be written there in dust. For a moment, you imagine 3i/ATLAS as a lonely traveller adjusting its pace to match ours, easing into our neighbourhood so we don't panic. The idea is absurdly comforting. Then the rational voice returns. Gravitational anomalies, data lag, miscalculations, you cling to those explanations like life rafts. Still, as the days pass, a quiet pattern emerges. Every time Earth rotates once, the comet's brightness pulses faintly, as if syncing to our day-night cycle. Astronomers call it coincidence. You call it curiosity saying hello. You step outside again at dusk. The air carries that same metallic scent. You tilt your head back, scanning the bruised purple sky. Somewhere beyond sight, 3I/ATLAS drifts on. Neither guest nor invader, a piece of nowhere learning the rhythm of here. You realise that for all our equations and telescopes, we still measure the universe mostly in feelings. Awe, fear, wonder, the occasional existential crisis. You smile into the darkness and whisper the only greeting that feels right. Stay as long as you need. You tell yourself you'll sleep early tonight, but of course you don't. Curiosity is a stronger stimulant than caffeine. The glow of the monitor paints your room in aquarium light, and your reflection looks like some deep-sea creature waiting for a flash. You've opened the new photometric data released from the Mauna Kea Observatory. Numbers, colours, brightness, wavelengths. Ordinary photons, allegedly. Yet as you start comparing them to known comet spectra, something feels off. The photons aren't behaving like they should. They're lying. A normal comet reflects sunlight in predictable ratios. Blue for ionized gas, red for dust, infrared for heat. 3I/ATLAS, however, reflects 2 green. Not the pretty mint of carbon molecules, but an electric emerald like neon trapped in ice. You adjust for exposure, for instrumental noise, even for the Earth's atmosphere. The anomaly stays. It's as if the object's surface bends the light itself, forcing photons to arrive with memories they never had. Your cursor hovers over a table of reflectance values, nickel lines, cobalt hints, a spectral shoulder near 540 nanometers that doesn't belong anywhere. One astrophysicist on a forum jokes, "If this were a lab sample, I'd assume someone spilled antifreeze." Another replies, "Or circuit boards." You smirk, then stop smirking. Historians still argue whether Newton's prism experiments truly convinced him that colour lived inside light, or whether he simply liked neat diagrams. Whatever the truth, you feel him sighing through time, muttering, "Those photons have some explaining to do." The telescope team posts their calibration images, flat fields, dark frames, all perfect. So the weirdness isn't the camera, it's the comet. You replot the data using different colour filters. The same impossible slope appears. You try to ignore the small thrill running down your spine. Maybe it's just systematic error, maybe not. In the next release, the European Southern Observatory publishes high-resolution spectra from the Very Large Telescope. There's the usual fingerprint of water ice, carbon monoxide, sodium. Then, right where a quiet void of nothing should be, an emission at 482.1 nanometers. You frown. That wavelength belongs to no known element. The official summary calls it unidentified. The amateur community calls it alien green. You prefer the colour of questions. Scrolling deeper, you find comments speculating that the emission might be the signature of ionized titanium hydride, something that shouldn't survive in open space. A chemistry professor tweets, "If that's correct, I'll eat my spectrograph." The tweet racks up 50,000 likes and 0 follow-ups. Later that week, a photo from the Hubble follow-up spreads across every science page. The nucleus gleams with that same unearthly hue. You zoom until pixels break apart like salt crystals. Around the core, faint threads twist into spirals, patterns too regular to be random. You whisper fractals and think of snowflakes, neurons, city maps. Everything in nature loves patterns. It's repetition that makes the universe comfortable. But these spirals are almost mathematical in their perfection, like the blueprint of a thought. A fringe site claims to have decoded the spiral ratios and insists they align with prime numbers. You scoff, but you still check. They don't match perfectly, yet they're close enough to itch your brain. You imagine some ancient architect sculpting numbers into ice and letting them drift across interstellar space like postcards. A new batch of measurements arrives. Albedo near 0.32, unusually bright for a comet. High reflectivity means smooth surfaces, not the dusty chaos we expect. Polished, someone writes in the data notes. That word bothers you more than any scientific term could. Polished means intention. At 3 a.m. you open your window for air. The night is syrup thick, moonless. You picture 3I/ATLAS far above. Photons bouncing off its alien skin, some bending toward your retinas right now, whispering the truth through their speed. Every photon is a messenger from the past. This light left the comet hours ago. You think of them travelling in perfect lines, carrying lies lovingly wrapped in green. In a rare moment of humour, you post online, "Comet gaslighting the entire solar system." It gets 4 likes, 1 concerned emoji, and 1 reply. It's not the comet that's lying, it's our models. You click the user profile, blank, no posts created yesterday. The account vanishes a few hours later. 2 days later, a data analyst publishes a paper claiming the green emission could come from ionized dicyanoacetylene, a molecule previously observed only in Titan's atmosphere. That would make 3I/ATLAS chemically similar to Saturn's moon, a familiar comfort. But within hours, another team posts a rebuttal, arguing that the molecular band doesn't match. You watch academics duel politely through PDFs, their equations clashing like swords made of spreadsheets. Historians still argue whether scientific revolutions happen in a flash or through slow erosion. Right now, you're witnessing erosion, the slow crumble of certainty. Then come the polarization measurements. Light from 3I/ATLAS twists 90 degrees compared to expectation, meaning the surface scatters photons in a pattern typical of crystalline lattices. You stare at the graph until your eyes ache. A crystalline lattice several kilometers wide? Impossible. Unless the entire object is one gigantic structured crystal. An interstellar snow globe built by physics or something worse. You spend an evening reading about the 1887 Michelson-Morley experiment, the one that proved there was no luminiferous ether. Funny how people once believed light needed a medium to travel through. Now you almost wish that myth were true, because at least then the strange photons of 3I/ATLAS would have a place to hide their secrets. A live stream from the Keck Observatory shows new colour composites. The astronomer on screen explains, in the calm voice of someone trying not to spook investors, that the comet's surface seems to re-emit captured light in slightly shifted frequencies. He calls it photonic delay. You call it echoing. Light that echoes, there's poetry in that, and dread. You start to wonder if the comet is less a solid object and more a kind of cosmic prism, storing light and replaying it on command. A recorder of starlight from its journey across galaxies. You imagine it carrying the afterglow of 1,000 suns inside its ice, whispering history through wavelengths. You'd give anything to listen. Late at night, your monitor flickers just once. The photo viewer freezes on one image of the comet. For half a second, the colour balance shifts. Turquoise fades, amber blooms, then it reverts. You replay the file, nothing repeats. Maybe a glitch, maybe not. You save that single frame anyway and label it the blink. A friend messages you a link to a declassified 1960s CIA report describing anomalous orbital object emitting polarized light in Lyra region. The attached microfilm scan looks too convenient, too crisp to be genuine. Still, the coordinates match the general direction of 3I/ATLAS's origin. You don't believe it, but you also don't delete it. The next morning, clouds roll in, smothering the sky. You feel oddly grateful. It's easier to rest when the heavens are hidden. Yet even behind the clouds, you sense the comet still shining, photons threading through vapor and memory. Historians of physics like to quote Einstein's letter, where he admitted that every light quantum carries a certain independence. You picture each photon from 3I/ATLAS as a tiny rebel refusing to obey our expectations, smuggling alien information across the void. Maybe that's what makes the universe so endearing. It never quite tells the truth. In a rare lucid dream, you find yourself floating beside the comet. The surface beneath your hands hums faintly, like a machine cooling down after long use. Its colour shifts as you breathe, green to gold to silver, as if responding to your pulse. You whisper, "Why are you lying?" The light answers with warmth, not words. When you wake, your palms feel cold. You check your email. A joint statement from several observatories announces temporary re-evaluation of photometric results pending further calibration. Bureaucratic code for something doesn't fit, but we don't want headlines yet. In frustration, you print the spectral plots and tape them to your wall. The curves resemble mountain ranges, peaks where colours flare and fade. Between two of those peaks, You notice a faint dip forming a symmetrical valley exactly halfway between frequencies, like an intentional pause. You trace it with your finger and realize it forms a simple binary rhythm, on, off, light encoded as beat, a language written in deception. You lean back, the hum of your room blurring into white noise. Maybe those photons aren't lying after all. Maybe they're editing themselves, translating a message too complex for our instruments. The thought is absurd, exhilarating, terrifying. You grin despite yourself. If the universe is playing riddles, at least it finally found a worthy audience of insomniacs. You turn off the monitor, letting the afterimage burn behind your eyelids. Even in the dark, you can still see the green shimmer pulsing like a heartbeat. Somewhere out there, light that has travelled across 1 trillion kilometres decides what story to tell next. You pull the blanket closer, whisper a goodnight to the dishonest photons, and drift toward dreams made of colours that never existed. You wake to numbers, not an alarm, not a notification, just numbers looping in your head like a half-remembered melody. 1.034, 58.2, to 482.1. The values from last night's data cling to your dreams like static. You stumble to the desk, open your laptop, and stare at the newest orbital update. The curve has changed again. It's subtle, half a degree of deviation, but in celestial mechanics, half a degree is an earthquake. Your simulation software loads with its usual fan-like sigh. You feed it the updated parameters, watching dots and vectors bloom across the black screen. The model runs for a minute before collapsing into nonsense. Velocity spikes to infinity. Orbital lines tangle like spaghetti, the program crashes. You rerun it. Same thing. The comet's math refuses to hold still. You mutter, ghost math, under your breath. It fits too well. Numbers that exist, but only long enough to haunt you. Historians still argue whether Isaac Newton believed his gravitational laws were divine truth or merely convenient scaffolding. Either way, you imagine him frowning at your screen, powdered wig askew, whispering, "The apple never behaved like this." To make sure it isn't your mistake, you try other tools. You run the orbit through JPL's Horizons database, then through an independent amateur algorithm nicknamed Comet Cruncher. Both crash. Both spit out the same error, non-convergent solution. That phrase, once harmless, now feels like the universe saying, "I decline to answer." On social media, astronomers start joking about 3I/ATLAS being unsolvable. A meme circulates showing Einstein erasing a blackboard while the caption reads, "When the comet refuses to math." You laugh, but it's a nervous laugh, the kind that sounds like tapping a cracked glass to see if it'll break. You add extra variables, Jupiter's perturbation, solar wind drag, hypothetical mass loss. Nothing stabilizes the model. Yet curiously, if you add a phantom mass just beyond Neptune, the numbers behave. The orbit straightens, the trajectory flows like silk. You freeze. That phantom would need to be roughly Earth-sized. The rational part of your mind reminds you of the 2016 debates about Planet 9, that mysterious supposed world tugging at the Kuiper Belt. Observations remain inconclusive. Historians still argue whether the evidence points to a real planet or a collective illusion born of small sample bias. You chuckle softly. Astronomy loves its ghosts. Maybe you've just rediscovered the same one. Still, you run the calculation again. Each time, the phantom mass brings order. Remove it, and chaos returns. You feel like a magician whose trick only works when no one's watching. You post the finding anonymously to an astronomy forum, under the handle Lyraghost. Within hours, replies flood in, some helpful, others mocking. One astrophysicist writes, "Your datasets overfit. Stop summoning planets to fix your mistakes." Another, more curious, messages privately, "Send me the raw residuals." You do. Minutes later he replies, "That pull doesn't look random." You stare at the words for a long time. That pull doesn't look random. It's the kind of sentence that can ruin sleep for a month. You minimize the window and glance outside. Clouds drift past a dim half-moon, its edges blurred like chalk. You imagine 3I/ATLAS beyond them, tracing its invisible spiral through the dark, dragging equations out of alignment as it goes. Somewhere in that dance lies a truth your software can't yet name. The next day, the University of Cambridge releases an internal memo, leaked within hours of course, suggesting possible non-gravitational acceleration inconsistent with sublimation models. Translation: it's moving on its own again. The data tables include a term you've never seen before, MUX, an undefined coefficient marked external influence parameter. You grin despite yourself. Even professionals need ghost math when the universe stops cooperating. You print the trajectory plots and tape them beside last week's spectral charts. The wall now looks like a detective board from a space noir movie. Lines, circles, scribbles, a few coffee stains. You whisper, "Okay, show me the pattern." The graphs stay silent, smug in their refusal. To clear your head, you walk to the local planetarium. The receptionist, an elderly volunteer named Hal, recognizes you. "Back to visit your girlfriend in the sky," he jokes. You smile weakly. Inside the dome, the projectionist is running an old program about cometary orbits. You sit under the artificial stars, watching white arcs trace elegant ellipses. None of them behave like 3I/ATLAS. The narrator's calm voice explains Kepler's laws, the harmony of spheres. You almost laugh out loud. Harmony feels like a rumour tonight. Historians of science sometimes quote Kepler's letters to Tycho Brahe. "I am stealing the secrets of the heavens by the sweat of my brow." You wipe imaginary sweat from your own forehead. Maybe the heavens have upgraded their security. Back home you dive deeper. You pull out datasets from older comets, Halley, Hale-Bopp, Borisov. Their residuals look chaotic but friendly, like scribbles by a distracted child. 3I/ATLAS's residuals, by contrast, form almost straight diagonal lines across your graph. Straight lines in error plots are bad news. They mean something consistent, something unseen, is tugging every data point the same way. You overlay those residuals onto a star map. The alignment points not toward Neptune, not toward Planet 9's suspected zone, but toward an empty region near the constellation Draco. You zoom in, expecting nothing. Instead, you find an old infrared survey hit, barely noticeable, a faint cold signature catalogued decades ago and forgotten. The archived note simply reads, "Possible rogue object." Non-confirmation. You whisper, "Oh, of course it's Draco," the dragon. The sky has a sense of humour. Your brain offers a half-formed possibility. What if 3I/ATLAS isn't being pulled by that unseen mass but tethered to it? Two fragments of one larger system, separated by cosmic time, like binary stars, but with one member invisible. Ghost math indeed. At 3 a.m, you message the astrophysicist who asked for your residuals. "Ever seen paired trajectories like this?" His reply arrives instantly, which means he's awake too. Only in simulations of controlled flight. You stare at the words, heartbeat sinking to the cursor blink. Controlled flight. You tell yourself he means spacecraft, not intention, but intention fits too well. Unable to resist, you run a predictive model. What happens if that phantom mass suddenly stops exerting force? The comet's path curves directly toward Earth's orbital plane. The simulation ends with a bright red impact marker labelled probability negligible. The word negligible doesn't comfort you. It never does. Historians still argue whether the famous Tunguska event of 1908 was a comet fragment or a meteor. Some fringe theorists once claimed it was an alien craft exploding mid-air. You chuckle nervously and promise yourself you won't add 3I/ATLAS to that pile of nonsense. Then you immediately open a file titled Impact Scenarios. So much for promises. In the following week, a small observatory in New Zealand reports an anomaly. When they track 3I/ATLAS against background stars, the residual drift oscillates in a repeating pattern. Tiny accelerations every 47 minutes. You recognise the number instantly. It's the same rhythm as the brightness pulse you recorded weeks ago. The math ghosts are tapping Morse code. You start plotting those acceleration spikes. When you map them against time, they form a clean sine wave. That kind of precision doesn't belong to random outgassing. It looks designed. Yet design requires a designer, and you're not ready to meet whoever's running that spreadsheet. Around this time, online debates explode between two camps, the It's Just a Rockers and the Alien Engineers. You lurk quietly in the comments, watching civilization reenact Galileo's trial in real time, fear disguised as skepticism. Someone quotes Arthur C. Clarke, "Any sufficiently advanced technology is indistinguishable from magic." You reply, "Or from math that refuses to show its work." Days pass. Your wall of printouts grows denser. Equations snake into the corners of sticky notes. One night you catch yourself drawing the same curve again and again, a looping spiral nested within itself. Only later do you realize it matches the comet's projected path if the phantom mass were orbiting in sync. You've invented a ghost binary. The next update from NASA quietly alters the predicted closest approach date by 13 hours. 13. You grin. Superstition loves precision. Officials blame refined modelling parameters. You know better. Refinement means someone added new data they don't want to explain. For comfort, you revisit the 1970s Pioneer and Voyager trajectories. Those probes also experienced unexplained deviations later dubbed the Pioneer anomaly. Decades of study eventually pinned it on uneven heat radiation. But you remember reading that, before that mundane explanation, a few scientists privately wondered whether the probes had passed through a subtle gravitational wake. Maybe 3I/ATLAS is surfing the same unseen tide, a current flowing through the solar system that we still can't map. You sit back, eyes gritty, the glow from your monitors outlining dust motes like tiny planets. Somewhere, equations are laughing at you, yet you can't look away. You tweak constants, chase decimals, chase ghosts. Every time you think you've trapped the orbit, it slips free like water between fingers. It's dawn when you finally shut the laptop. The sky outside has that pale pre-sun glow, bluish-grey like worn steel. You whisper, "Fine, have it your way." The numbers won't listen, but maybe the silence will. You realise with an exhausted grin that the ghost math isn't a problem to solve. It's an invitation. Something out there is rewriting the rules one decimal at a time, daring you to follow. You pour the last of yesterday's coffee, cold and bitter, and raise it like a toast toward the invisible heavens. To the unsolvable, you say softly. The liquid trembles from the pulse of your hand, a tiny wave that refuses to settle, just like 3I/ATLAS, tracing its impossible arc through the dark. You don't notice the silence at first. It sneaks in like humidity, soft and invisible. One night you open the Chilean Observatory's live stream, an array you've relied on for weeks, and the feed just isn't there. The channel loads, buffer wheel spinning, then a polite grey message. Maintenance downtime. You shrug. Servers crash all the time. But then you check their social media, and the last post is from 2 days ago. A photo of a technician smiling beside one of the domes captioned "Clear skies tonight." After that, nothing. You try the official website. Down. The backup mirror? Down. An astronomy subreddit thread pops up titled, "What's going on at Cerro de las Manos?" And suddenly, the hum of your fan sounds louder than it should. The array there, 6 synchronized telescopes built into the Atacama Plateau, was among the first to photograph 3I/ATLAS's hexagonal shimmer. Its data vanished the night the object brightened. Historians still argue whether censorship ever touched early astronomy, how Galileo's notebooks contained quiet erasures, how Soviet observatories once renamed comets for politics. Maybe some patterns repeat. You tell yourself this is just coincidence, maybe a cybersecurity glitch, maybe desert power lines. You don't believe it, but the lie tastes easier. You dig through cached pages, half-functioning archives. Every trace of last week's imagery is gone except one mirrored thumbnail. 3 kilobytes of blurred turquoise. When you zoom in, digital noise blooms like frost across glass. You almost think you see tiny geometric lines inside the smear. Then your monitor flickers and goes black. You sit there in the dark for a long minute, heartbeat syncing with the fan's wobble. When the screen revives, your browser reopens automatically to a blank page titled Untitled. You check the cache history. It's empty, like someone vacuumed the night clean. The next morning, major outlets announce routine maintenance at the Chilean facility. They quote a brief statement about server upgrades and lens recalibration. The tone is too warm, too rehearsed. You've heard similar voices announcing weather balloons. A few hours later, amateur astronomers begin sharing their own stories. A woman in Finland posts that her remote telescope account, one of those rentable rigs in Chile, was suspended without refund. Another user shares an email screenshot reading access temporarily restricted due to proprietary data capture. Proprietary, you think, the most polite synonym for classified. You start compiling a timeline. The last confirmed image from the array, 2:17 UTC. The exact minute 3I/ATLAS's luminosity curve spiked by 18%. You overlay both datasets and whisper, "Of course." For the first time, you feel something heavier than curiosity, a slow, delicious dread. Whatever happened, someone somewhere decided the public didn't need to see it. You text Mireia in Argentina, the live streamer who once whispered "Está vivo." She replies fast, "My feed from Cairo node died too. They told me to wait. You picture her pacing beneath southern stars, frustrated and wide-eyed. Then another message appears. They asked me to sign an NDA, non-disclosure. She sends a photo of the document header before deleting it. That night, you can't concentrate. You scroll through every platform hunting for mirrors of the vanished data. In a dark corner of the web, you find a compressed archive labelled ATLAS-ghost.zip. It's only 12 megabytes, too small for full-resolution astrophotography, but curiosity trumps caution. You download it anyway, half expecting malware. Inside are 6 low-quality images and a text file titled, "They're not stars." The photos show the comet's coma as seen through different filters. In the ultraviolet frame, faint dots appear around the nucleus, equidistant 6 of them. You measure the spacing. Perfect symmetry, like the vertices of a hexagon. In the visible light frame, the dots vanish. You sit back, eyes burning. Are those reflections? Lens ghosts? Or smaller fragments orbiting the main body like, no, don't say satellites. Even thinking the word feels like crossing a line. Historians of exploration might remind you that secrecy often shadows discovery. The Manhattan Project built an entire scientific city under wraps. The 1960s Corona satellites photographed half the planet before the public knew they existed. Maybe astronomy just joined that tradition of strategic silence. But then again, comets don't classify themselves. 3 days pass without any official update. The Atacama Observatory remains offline. You notice other facilities suddenly focusing elsewhere. Press releases about exoplanet studies, asteroid deflection conferences, anything but 3I/ATLAS. It's as if the cosmos has lost its headline act. You check the public tracking coordinates. The comet symbol is still there on the map, but the data refresh stops at the exact timestamp of the outage. Every new attempt returns awaiting confirmation. You picture astronomers in quiet panic telling interns to unplug servers and reboot reality. One evening you dream of the array itself. 6 domes open under the Milky Way, motors whining. But instead of stars, the telescopes point at a turquoise shape descending toward them. Its light floods the desert like dawn compressed into seconds. The next moment, all 6 domes close at once. Silence. You wake with the taste of ozone in your mouth. You spend the day hunting for any mention of personnel. The facility's staff page disappears, replaced by a cheerful under-construction graphic. But on an obscure LinkedIn update, a technician posts, "Taking time off." Strange week. The post vanishes within an hour. Then comes a leak. 3 low-resolution stills purportedly from the missing observatory, uploaded anonymously. They show 3I/ATLAS, flaring so bright it washes out nearby stars. In the third frame, the core shape looks angular. Not perfectly round, but with straight edges like facets of a gem or panels of a machine. Commenters argue it's a sensor glitch. Others note the symmetrical diffraction pattern. You just stare, realizing your own spectral data hinted at the same structure weeks ago. By midnight, the images vanish. Websites hosting them display content removed due to copyright claim. You grin. Copyright on a comet. There's a first. You start recording your screen during every search, just in case the internet itself starts forgetting again. The folders on your hard drive multiply like rabbits. Atlas_A, Atlas_B, Atlas Ghost, backup of backup. Each one a shrine to something that maybe never existed. Historians still argue whether the 1938 radio broadcast of the War of the Worlds actually caused panic, or whether later retellings inflated the hysteria. Either way, people love the myth of a public fooled by fiction. You wonder if, in some future lecture, 3I/ATLAS will be cited the same way. An internet-era panic fueled by doctored photos and sleepless imaginations. The thought stings a little. You try to shake off paranoia by watching ordinary news, politics, sports, celebrity birthdays, all mercifully human. Yet even those broadcasts feel thinner now, like shadows cast by the missing data. You realise the silence from the observatory has infected your sense of normalcy. Then, without warning, the feed returns. A bland press release announces successful maintenance completion. The new public images look clean. Too clean. The comet appears dimmer, smaller, perfectly spherical. You cross-compare with pre-shutdown data. The brightness profile has been flattened, the green emission muted. Someone has massaged the cosmos. In one frame, though, they miss a pixel. Off to the right of the nucleus glimmers a faint hexagonal ghost. The same 6-point pattern as before, barely visible unless you boost contrast. You stare until your eyes ache, then laugh quietly. The universe always leaves typos. You upload a comparison collage to a forum, marking the hidden shape. Within an hour, moderators delete your post for image manipulation. You re-upload elsewhere. Same result. By the third deletion, you realise it's not algorithmic moderation. Someone's watching. You glance at your webcam instinctively, then cover it with a sticker. At 2 a.m, Maria messages again. They told me not to stream tonight. Said they're recalibrating optics. You ask who they are. She replies with a single emoji, a lock, then goes offline. You can't help laughing, a shaky exhale that feels half hysteria, half awe. You whisper to the dark room, "All right, Atlas, keep your secrets." The fan hums approval. Still, you notice one comforting truth buried in the censorship. If someone wants silence this badly, there must be something worth hearing. The universe doesn't hide its rocks, only its revelations. Before bed, you check the observatory's live sky again. The cameras show serene stars unblinking, but for a fraction of a second, one frame catches a turquoise flare low on the horizon. Then static. Maybe lightning, maybe truth. You smile, knowing you'll never be able to tell the difference, and that's the fun part. You close your laptop and whisper, "Good night, ghost watchers." Outside, the wind from the Atacama crosses half the world to reach your window, carrying the faintest scent of metal and dust, the perfume of machines that saw too much. You tell yourself it's just data compression, that artifacts happen when light and algorithms collide. But deep down, you already know you're lying. The latest batch of public images from Cerro de las Manos doesn't look natural. Each pixel seems to twitch when you're not looking directly at it, like static that's aware of being observed. It's close to midnight. Your monitor glows the colour of old ice. You drag the raw FITS files into your viewer program frame by frame, enlarging the region around the comet's nucleus until the stars blur into soup. And there, tucked inside the noise, something geometric breathes. At first it's faint, just a cluster of 6 bright points forming a ring around a darker centre. But as you stretch the contrast, the ring becomes a shape, hexagonal, sharp-edged, eerily consistent across multiple exposures. You mutter, "lens reflection," because that's what a sane person would say. Yet the pattern stays perfectly aligned even when the telescope slews a few degrees. Historians still argue whether the earliest photographic plates ever captured illusions or genuine discoveries, whether Percival Lowell truly saw canals on Mars or only the veins in his own eyes. Tonight, you sympathise with him. You too are staring at a pattern your brain insists on completing. You run noise reduction filters, the edges sharpen. A tiny filament extends from one corner of the hexagon like a tail, or a cable. You blink hard, half expecting the illusion to vanish. It doesn't. The pixels stare back. You lean closer until your breath fogs the glass. The hum of your desk fan syncs with your heartbeat. Somewhere in the circuitry, you swear you can hear the soft tick of the computer's clock keeping time with distant starlight. You remember reading that in 1979, NASA engineers discovered hidden binary streaks inside the Voyager 1 photos. Data bleed from cosmic rays. Maybe that's all this is. The universe doodling across your hard drive. Still, curiosity wins. You isolate the hexagon region and perform a Fourier transform to look for periodic signals. The result explodes into spikes, spaced exactly 27 pixels apart. That spacing shouldn't exist in natural noise. You feel the hairs rise along your arms. You joke aloud, "Great, I've discovered interstellar wallpaper." The sound of your voice feels strange, as if the room's acoustics have thickened. To clear your head, you open a folder of older images from the same telescope, control frames of random star fields. None show the pattern, only 3I/ATLAS does. You mutter the coordinates like a mantra, grounding yourself in numbers. Historians of technology note that early digital photography introduced a new superstition, the belief that hidden messages lurk inside static. People saw faces in television snow, ghosts in low bitrate shadows. Maybe you're joining that long tradition. You hope so. Still, you keep digging. You stack multiple frames from different nights, aligning the stars perfectly to cancel drift. When you average the exposures, the noise should flatten. Instead, the hexagon becomes brighter. Averaging amplifies it. You sit back, stunned. Randomness doesn't add up to structure, unless the structure was real all along. Your phone buzzes. A message from Mireia. Look closer at the tails. You type back, which tails? But she's already offline. You scroll through the frames again and notice faint streamers extending from the comet's coma at regular angles, 60 degrees apart like spokes. Ordinary comets spew gas in chaotic fans. These look engineered. A tiny laugh escapes you, half delight, half disbelief. Sure, you whisper. Perfect geometry, why not? The fan clicks in lazy agreement. You decide to test a theory. If those spokes are real, they should rotate as the comet spins. You compare images taken hours apart. The hexagon remains fixed while the tails twist clockwise by about 15 degrees. That means rotation. You estimate a period, roughly 47 minutes again. The same number that haunted the brightness curve, the acceleration spikes, everything. 47, the universe's favourite inside joke. You write it in the margin of your notebook. 47 equals heartbeat. Then, because you can't help yourself, you convert the pattern into sound. You map brightness to pitch, time to rhythm, and let the program play the image as audio. The result is a low hum rising every 47 seconds, subtle but deliberate. It sounds almost like breathing. Historians still argue whether the wow signal detected in 1977 was extraterrestrial or just an earthly reflection, but they agree on one thing: it made people listen differently. You sit in the dark now, listening differently too. The digital hum fills the room, gentle, mechanical, alive. You upload a compressed version of the sound to an astronomy forum with the caption "Light Translated." Within minutes, someone comments, "It's Morse code." You roll your eyes until another user posts a translation. "Hello." You freeze. It's too neat, too human. Probably coincidence, an overeager algorithm interpreting noise, but still. The word hums through your speakers again. "Hello, hello, hello." You shut the laptop. The silence afterward feels heavier than before, as if the air itself resents the interruption. To distract yourself, you dig into the observatory's metadata, checking exposure timestamps. The last 3 images show something odd. The file creation times differ by exactly 47 minutes. You laugh nervously. Coincidences are starting to feel like choreography. Later that week, an anonymous email arrives from a Proton Mail address titled Calama Intern. The message is short. Don't trust the calibration images. They're not calibration attached, is a single file, a 300 kilobyte PNG. You scan it for viruses. Clean. It's a photograph of one of the observatory domes under moonlight. The metal shell gleams faintly turquoise, like reflected comet light. You zoom in. Across the curved surface, burned into the alloy, are 6 small hexagonal scorch marks. You whisper, "No, that's lighting." But deep inside you, something whispers back, "Sure it is." Historians of espionage love recounting the 1980s KGB incident, where cosmic ray streaks on satellite film were mistaken for secret transmissions. Maybe this is your modern equivalent, a trick of physics inflated by paranoia. Still, the scorch pattern looks too familiar. You post the image privately to a small Discord group of astrophotography enthusiasts. Half think it's fake. One suggests meteor dust. Another member, a digital forensics expert, enhances the shadows and points out faint lettering between the burn marks. SEE. The chat erupts. Someone jokes that the comet's telling us to see. You type a smiley face and close the app before panic takes root. That night, sleep refuses to visit. You lie in the dark, imagining those pixels pulsing on some distant server, a message too faint to notice unless you already believe. You wonder if belief is the final filter in every dataset. When dawn seeps through the blinds, you open the files again. The pattern still waits, unchanged, patient. You trace the 6 points with your cursor, connecting them into the familiar hexagon. At its center lies a single dead pixel. Black. Absolute. You stare until the afterimage burns into your vision. For a heartbeat, you think it flickers. You murmur, "I see you." The cursor trembles as if acknowledging. You laugh at yourself the way lonely people laugh when the fridge hum answers. Still, you whisper a quieter apology. Outside, birds argue over breakfast, unaware that somewhere beyond Jupiter, a hexagonal enigma spins and hums hello. You close your eyes and let the morning light wash the turquoise ghosts from your retinas. Historians still argue whether discovery requires proof or simply persistence. You decide it's both, and that persistence sometimes means staring into noise until it blinks back. You save all 6 images to an encrypted drive labelled pixels_from_void and hide it among tax documents. The sound file, though, the breathing hum, you keep on your phone. Every so often you press play just to make sure it's still there, that the cosmos hasn't rescinded its greeting. Tonight, when the room goes quiet enough, you swear you can hear the pattern underneath the fan's drone. A pulse every 47 seconds, steady and kind, like the heartbeat of something waking up far away. You're halfway through reheating last night's coffee when your inbox dings. Subject line, FW, internal comms do not distribute. The sender field is blank, as if the message had slipped through time instead of a server. Your pulse quickens. You open it before common sense can intervene. Inside sits a single link to an FTP directory on a NASA subdomain, along with one sentence. If you still think it's just a rock, check this. You hover over the link for a full minute, debating whether this is how malware introduces itself. Then curiosity wins, as it always does. The directory loads sluggishly, a relic from the early internet, grey interface, monospace text, a handful of files with government-flavoured names, a TLAS_spectra_memo17.engine_exhaust.png. You whisper, "Oh, come on," half laughing. The caffeine tastes metallic. You click the memo first. It opens as a PDF of scanned pages. The header reads Jet Propulsion Laboratory, Inter-Office Correspondence, Confidential. Paragraphs of dense jargon scroll past, thermal corrections, spectral calibration, possible emission artifact. Then one line stops you cold. Compare current emission profile to recorded exhaust patterns from Voyager RTG plume tests, 1977 to 1978. Similar amplitude, exhaust patterns. The phrase feels wrong in the mouth of astronomy. You reread it twice, tracing the letters with your fingertip like a spell. Historians still argue whether the Apollo 11 transcripts were ever subtly edited before public release. You think about that as you scroll to the memo's footnote. Pending confirmation, advise discretion with external media. The document ends there, abruptly, without a signature. Next you open engine_exhaust.png. The image is grainy, almost abstract. A narrow plume of light fanning from the comet's tail, captured through infrared filters. Overlaid are measurements, arrows, equations. At first you think it's mislabeled, something from a propulsion test. Then you recognize the faint hexagonal halo around the source point. It's 3I/ATLAS, unmistakable. The FTP server stutters, connection flickering. You right-click, save a local copy. Halfway through the download, the bar freezes at 47%. Of course, 47. You grin despite the chill crawling up your spine. The file completes after a pause long enough to make you doubt electricity itself. You lean back, staring at the image. The plume isn't random like gas venting. It's collimated, narrow, almost engineered. If the data is genuine, the comet isn't drifting. It's accelerating under its own power. The thought lands heavy, absurd, exhilarating. A tiny pop-up window appears. Connection lost, server unavailable. When you refresh, the directory is gone, replaced by a 404 error. You whisper, "I knew it," both triumphant and terrified. Historians of science love quoting Galileo's private letters, where he admitted to seeing more than I should. You figure he'd understand this moment, the thrill of forbidden pixels. You spend the afternoon cross-checking. You dig up every public spectral dataset, comparing them to known engine emissions. The resemblance is uncanny. Faint titanium oxide peaks, micro oscillations around 482 nanometers, just like rocket exhaust through thin vacuum. You laugh at the insanity of it. Maybe some chemical coincidence. Maybe. By evening, astronomy Twitter is aflame. Someone else must have glimpsed the same leak. Screenshots circulate before vanishing. Hashtags bloom, hashtag Atlas Gate, hashtag Comet Drive, hashtag Space Scandal. Then the deletions begin. Posts vanish mid-scroll, accounts lock themselves. Official NASA feeds post cheerful distractions about the moon's craters, the digital equivalent of whistling past a graveyard. You join a live stream hosted by a jittery journalist named Ravi, broadcasting from what looks like his kitchen. He's sweating under fluorescent light, reading from notes. Multiple insiders confirm a data breach involving interstellar object 3I/ATLAS. Sources describe propulsion-like signatures. His stream lags. The chat explodes, some laughing, others quoting scripture. Then the feed cuts. You refresh again and again, but the channel's gone, terminated for violating community guidelines. You close the browser slowly, heartbeat loud enough to feel in your throat. Later that night, you receive another anonymous email. No greeting, just coordinates, a timestamp, and a single line. Watch infrared bands between 2.1 and 2.3 microns at this time. You set an alarm, and when the moment arrives, you log into a public telescope feed run by a university in Arizona, one of the few still tracking 3I/ATLAS. The feed shows a faint, steady glow, nothing unusual. Then, at precisely the given second, the comet brightens in infrared while dimming invisible light. It's like watching something inhale heat and exhale darkness. You record the event, replaying it frame by frame. The bright pulse travels down the tail as if channeled through a pipe. A textbook energy transfer. You mutter, "Engine test, huh?" and laugh, because the alternative, acknowledging deliberate control, feels too large to name. Historians still argue whether Konstantin Tsiolkovsky, the father of rocketry, truly believed that advanced civilizations would explore space in cosmic arcs. He probably never imagined we'd mistake one for ice. At 3 a.m, your phone buzzes again. Another message from the unknown sender. They'll deny it tomorrow. Save everything tonight. You back up the files twice, encrypt them, copy them onto a flash drive you tape under your desk drawer. For the first time, the story feels personal, not cosmic. Morning brings the expected denial. NASA issues a brief statement. No propulsion signatures detected from 3I/ATLAS. Circulating documents are fabricated. You almost admire the efficiency. Yet the wording, no propulsion signatures detected, isn't the same as does not exist. You grin into your coffee. Lawyers write better fiction than novelists. By midday, fact-checkers flood the web calling the leak AI generated. You open your saved file and compare. The compression artifacts, the metadata timestamps, the analog film grain, too messy for synthetic forgery. You know the difference. Still, doubt creeps in. You message Maria. "Did you see the NASA leak?" She replies instantly. "They're cleaning up. Stay offline." Then nothing. To clear your head, you step outside. The day feels brittle, air humming with distant traffic. Overhead, the sky is brutally ordinary. No turquoise glow, no cosmic engines. You remind yourself that the universe rarely behaves for witnesses. You walk until you reach the river, watching sunlight fracture on water. It occurs to you that light itself is a leak. Photons escaping their stars, travelling centuries to tell on them. Maybe the universe was always a whistleblower. That night, insomnia returns with claws. You reread the memo again and again until the words blur. Engine exhaust. Discretion with external media. You imagine the meeting where those sentences were born. Fluorescent conference room, scientists shifting in chairs, someone finally saying, "What if it's not geological?" The silence that must have followed. Historians of modern secrecy often cite 1947's Majestic 12 myth, how a handful of forged documents created decades of conspiracy. You wonder if 3I/ATLAS will spawn its own mythology, emails and FTP ghosts replacing typewritten memos. Maybe you're already part of it. At 2:47 a.m, because of course it's 47 again, your phone pings one last time. A single audio file arrives named enginehum.wav. You hesitate, then play it. The sound is low, rhythmic, like wind through a tunnel or the deep throb of distant machinery. Beneath it, barely audible, a pattern of pulses. 3, 1, 2, 1. You check the timestamp, recorded exactly when the comet's infrared flare peaked. You let it play until the hum blends with your heartbeat. For a moment, the room feels weightless. You imagine 3i/ATLAS turning slowly in the dark, expelling invisible breath across space. Engine exhaust or exhalation, it no longer matters. The line between machine and life has blurred into the frequency of wonder. You save the audio, close the laptop, and sit in the dark, smiling. The world will keep denying, but the void has already spoken, and it sounds like the soft purr of the universe remembering how to dream. You swear you're going to take a break. You even tell yourself out loud, "No more data tonight, I'm done." But 30 minutes later, you're back at the desk, caffeine trembling through your veins, the monitor bright enough to sunburn reason. The leak, the denials, the hum in that audio file, it all loops in your head until curiosity starts feeling like hunger. So you do what every overeager scientist eventually does. You zoom too close. You open the highest resolution image you own, the last one taken before the Chilean blackout. Each pixel represents roughly 40 meters across the surface of 3i/ATLAS. You know the numbers by heart. You could probably sketch the coordinates in your sleep. You start enlarging the region near the comet's pole, clicking deeper, letting the interpolation blur into dream. Somewhere between 500 and 600% magnification. The noise smooths into patterns again, lines, right angles. Historians still argue whether the human brain's obsession with geometry is biological or spiritual, whether seeing patterns is how we survive or how we go mad. Tonight you feel both possibilities wrestling under your skin. The grid glows faintly, like circuitry hiding beneath frost. You think of the green emission at 482 nanometers, the one no database could name. Maybe it isn't chemistry at all. Maybe it's light reflecting off structure. Your mouth goes dry. You whisper, "No way!" even as your mouse drags the brightness higher. The shape sharpens. Tiny rectangular shadows aligned in rows, some overlapping, others half buried under translucent haze. They look like vents, or windows, or the pixelated ghosts of either. You lean back, forcing a laugh. "Artifacts," you mutter. "Compression junk." But your voice doesn't sound convinced. You remember the first time you saw satellite photos of Earth from orbit. The crisp order of cities, the faint orange webs of highways at night. If an alien somewhere was zooming on those, would they also mistake human light for artifacts? Or would they know we built ourselves into the planet? The hum from your old desk fan merges with the faint thrum in your headphones, the enginum.wav file you left looping quietly. Its rhythm seems to sync with your scrolling. Every 47 seconds, a pulse, and every pulse the pixels shimmer. You freeze the frame mid-pulse. The grid glows brighter. Historians of the early space age like to mention the Pioneer plaque, that gold anodized map we bolted onto a spacecraft to tell strangers where to find us. You can't help wondering whether 3i/ATLAS carries its own plaque, an entire hull engraved with directions. You increase contrast again. The noise forms a narrow corridor of darker pixels stretching from the nucleus outward, like a trench or channel. At the far end glints a single brighter dot. You measure its luminosity, too sharp for random reflection. It's as though something inside the object is looking back. You tell yourself to stop. Then you open the raw FITS headers, searching metadata for anomalies. In the comment line of frame 312, you find something you've never seen before. A string of repeating digits, 470047004700. You laugh out loud. Some engineer must have tagged the file that way, an inside joke. Still, you copy it into a text editor, curiosity clawing through fatigue. You convert the digits into binary, then ASCII out of habit. The text spells STAYBACK. Your breath catches. You blink hard, check your conversion. No error. You run it again using a different parser. Same result. You whisper, "That's not funny," to no one. For the first time since this obsession began, you feel something colder than awe. Not fear exactly, more like recognition. The sense that the universe just acknowledged your existence. You minimize the file and step away from the desk. The room tilts slightly, the way it does when you've stared at bright screens too long. In the hallway mirror, your eyes glimmer with that same faint turquoise from the monitor. You shake your head, blaming the glow. When you return, your computer screen is black. Not asleep, off. You press the power key. Nothing. The fan hum stops. The house feels vacuum silent. Then, without warning, the monitor blinks back to life, displaying a single image, the comet's hexagon, rotated 90 degrees, overlaid with faint text, "Do not adjust." You snort nervously, trying to rationalize. Maybe you left an image viewer window open. Maybe the GPU glitched. You snap a photo with your phone. Before you can check it, the screen returns to your desktop as if nothing happened. Historians still argue whether early computer pioneers like Turing ever imagined machines would unsettle their users. Probably not like this. You open the phone gallery. The picture is blank white noise, no trace of the warning. Yet buried in the metadata timestamp is that number again. 47 minutes, 0 seconds, 47 milliseconds. You start laughing too loudly. The sound borders on hysteria until it turns into hiccups. The fan resumes its lazy spin, grounding you back in the ordinary. You save every file to an external drive and unplug the computer. Then you sit in the dark, breathing through the caffeine tremors, replaying each frame in your mind. Maybe it was a data hiccup, maybe exhaustion. But the phrase "stay back" echoes with uncomfortable precision. Unable to sleep, you research historical instances of astronomical data talking back. There are none, of course, unless you count myths. You scroll through tales of comets as messengers of gods, portents of doom. Historians still debate whether the bright star over Rome in 44 BCE, the one everyone called Caesar's comet, was real or legend. Either way, people looked up and decided the sky had opinions. By dawn, exhaustion finally drags you to bed. Your dreams flicker in pixelated turquoise. You're floating above the comet's surface, the hexagonal hull stretching beneath you like a frozen cathedral. You reach out to touch the glowing grid. It pulses once, warm under your fingertips, and a voice, not sound but vibration, says, "Too close." You jolt awake. Morning light floods the room, harsh and human. You check the external drive, files intact. No new messages, no ghosts. Just the quiet ticking of the wall clock, every second perfectly ordinary. You spend the day pretending normal life still exists. Emails, groceries, the gentle absurdity of bills. Yet each mundane motion feels like acting in a world that's already changed. When evening comes, you find yourself back at the desk. Of course you do. You plug the drive in, open the images again, and try to recreate the glitch. Nothing. No warning text, no hidden binary. Just the cold geometry of alien ice. You sigh in relief and disappointment all at once. Then, on a whim, you overlay all 6 frames and reduce opacity to half. The combined image reveals something new. The hexagon's center forms a faint spiral of lighter pixels curling inward. A tunnel, maybe, or a symbol. The pattern reminds you of the galaxy itself, a miniature Milky Way carved into comet dust. You whisper, an invitation, before you can stop yourself. The fan clatters once like a laugh. You smile back. Historians will probably say you imagined it all. Fatigue, confirmation bias, pareidolia. They'll write papers about the Atlas effect, how a generation of insomniac watchers turned a wandering comet into a cosmic mirror. But they weren't here in this room, hearing a hum that matched their pulse, seeing pixels align like architecture. You close the laptop slowly. For the first time in weeks, you resist reopening it. Through the window, the night sky sprawls, black and unsuspicious. Somewhere beyond it, 3i/ATLAS keeps moving, maybe noticing your tiny attention the way a whale might feel a single plankton glance. You whisper, "I'll stay back." The stars don't answer, which is almost comforting. Silence, after all, is just another kind of data, one we haven't decoded yet. Days pass in a haze of ordinary life that refuses to feel ordinary. You try to ignore the hard drive labelled pixels _from_void tucked under your desk, but it hums at the edge of thought like tinnitus of curiosity. You tell yourself you've done enough, that the universe doesn't need another sleepless detective. Then, late one afternoon, an alert pings from a public spectroscopy feed. New emission lines detected from 3i/ATLAS. The headline says, "Possible novel element detected in cometary spectrum." And just like that, you're back in orbit around obsession. You open the dataset, fingers trembling a little. Each line of numbers represents light broken into confession. Most comets sing the same chemical lullabies: hydrogen, carbon, sodium, cyanogen. 3I/ATLAS, however, hums in keys no one recognises. There's the familiar peaks near 430 and 589 nanometers, but between them yawns a thin, fierce spike at 511.3. You frown. That region belongs to nothing on Earth, nothing in the standard cosmic library. Historians still argue whether Dmitry Mendeleev left blank spaces in his periodic table because he believed in undiscovered elements, or because he enjoyed neat symmetry. Either way, his ghost feels close tonight. You whisper, "Make room for one more, Dmitry." The report calls the feature line X, a placeholder so cautious it borders on denial. Laboratory analysts from 3 continents attempt to reproduce it by mixing every known combination of metals and ices under vacuum. None match. A fringe paper suggests it might be a metastable allotrope of hydrogen bonded with trace exotic matter. Another suggests camera noise. The comment section devolves into sarcasm and panic in equal measure. You download the raw spectra anyway, open them in your plotting software, and overlay last month's data. The new spike wasn't there before. Something on that comet changed. Elements aren't supposed to appear overnight. Chemistry doesn't do surprises, unless of course something was switched on. You lean back, rubbing tired eyes. The memory of the "stay back" message flashes through your mind. Maybe that wasn't a warning. Maybe it was instruction, because the moment you zoom too close, the object responded. The thought both thrills and terrifies you. To check yourself, you run a cross-correlation against known particle decay lines. The match that appears makes your skin crawl. The energy corresponds to electron-positron annihilation, matter meeting antimatter. You reread the value, 511 kilo-electron volts, right there in the photon data. 3I/ATLAS is emitting the same signature the universe gives off when it erases itself. Historians still argue whether the 1932 discovery of the positron by Carl Anderson was proof of symmetry or just a cosmic prank. Either way, you imagine him squinting through his cloud chamber muttering, "Not this big." You sketch a rough model in your notebook. If that annihilation line is real, the comet might contain pockets of trapped antimatter, neutralized by the surrounding ice, like a frozen reactor bleeding occasional light. But that would require engineering, containment, intention. You shake your head. Even saying those words feels blasphemous to physics. Later that night, the European Southern Observatory releases an emergency bulletin. They confirm the line, calling it an unidentified gamma-adjacent emission of unusual coherence. Translation: they don't know what it is, but it's stable, repeating every 47 minutes. You can't help smiling. The universe loves consistency. You imagine the reaction in labs worldwide. Scientists tapping pens, recalibrating detectors, whispering to colleagues, "It can't be right." Every revolution begins with that sentence. A friend from grad school messages you. "Our professor says it's a detector glitch." You reply, "Then why does every detector glitch the same way?" She doesn't answer. The following day, a new rumour surfaces. NASA has classified the next batch of spectral data. Amateur astronomers report their feeds suddenly ending mid-download. You're not surprised. The unnamed element has officially graduated from curiosity to secret. Historians of chemistry love to tell how Marie Curie handled radium with her bare hands, unaware of the danger glowing inside it. You wonder what invisible danger might be humming through the 3I/ATLAS light streaming into your computer. You decide to recreate the spectrum yourself using archived photometry. You don't have a lab, just algorithms, caffeine, and hubris. You align the wavelength axis, normalize intensity, and subtract background noise. The spike remains, stubborn and pure. You plot it in red. The rest of the spectrum looks like a heartbeat. The new line cuts through like a scalpel. You print the graph, tape it to your wall beside the hexagon images, and stare. It's beautiful, almost musical, a single note out of tune with the universe. You imagine what it would sound like if translated to audio, so naturally you try. You map frequency to audible range and press play. The room fills with a high, clear tone, piercing but strangely soothing, like glass singing. After a few seconds, modulation appears, faint rhythmic dips every 47 seconds again. You laugh softly. "All right, you win," you tell the invisible audience. Then your phone buzzes with an unknown number. You let it ring out of habit, but the voicemail transcribes as blank except for a single character. X. You feel the chill settle deep in your chest. To distract yourself, you dig into archives of ancient myths. Many cultures spoke of sky objects bringing new metals. The Greeks wrote of chalybs celestis, celestial steel. Chinese texts mention star iron forged from heaven. Historians still debate whether those accounts refer to meteorites or imagination. You wonder if someone, long before telescopes, saw a visitor like 3i/ATLAS and tried to describe an impossible element in human language. At dusk, you step outside, looking for the faint smear near Camelopardalis. You can't see it with the naked eye, but you know it's there, humming its unknown wavelength, bathing you in photons that break the rules. You close your eyes and imagine that new element falling through the atmosphere, slipping quietly into the periodic table like a stowaway. Back inside, your inbox flashes again. Anonymous sender, of course. Subject line, X-ray lab results. You open it cautiously. Inside is a single paragraph. Emission stable. Temperature correlation 0. Source may be coherent field rather than matter sample. In short, it's not an element, it's a signal. You reread the last sentence until your eyes sting. A signal disguised as chemistry. Historians of radio astronomy would have a field day. In 1967, Jocelyn Bell Burnell detected the first pulsar and briefly labelled it LGM-1. Little Green Men 1. You smile, remembering her humility, her insistence that it was natural. Humans always assume nature first. Sanity depends on it. Still, you can't help thinking, if an intelligence wanted to speak across interstellar distances, it wouldn't use sound or text. It would use physics, something that can't be censored or lost in translation, a wavelength no element owns. You record a voice memo to yourself. Maybe 3i/ATLAS isn't made of new matter. Maybe it's made of message. You laugh softly, then delete the file, embarrassed by your own poetry. Sleep comes in fragments. In one dream, you're inside the comet, walking through corridors carved of translucent metal. The walls pulse with turquoise light. You touch one, and the same clear tone from your audio experiment fills the air. Symbols spiral across the surface, numbers, waveforms, 47 repeating like a heartbeat. You ask, "What are you?" And the light answers, "Potential." You wake at dawn gasping, half expecting your room to glow. Only the monitor light blinks patiently. You sit up, rubbing your temples, realizing that dream or not, you finally believe it. 3i/ATLAS is trying to show something, and humanity is barely smart enough to misunderstand it. Over breakfast, you skim the news. A short statement from Issei downplays the spectral anomaly as data inconsistency, but the official chart they release accidentally includes a fragment of the true curve. You can see the edge of line X before it's cropped out. Proof hidden in plain sight. You chuckle. Bureaucracy's version of camouflage. You print that image too, taping it beside your other relics. The wall now glows like a shrine built to disbelief. As night returns, you open the hum file and layer the new tone of the unnamed element over it. Together they form harmony, two notes intertwining, rising and falling every 47 seconds. You sit back, eyes closed, listening. It sounds neither mechanical nor organic. It sounds like something between breath and logic. Maybe that's what the new element is. A bridge between physics and intention. A reminder that discovery often begins as music too faint to hear until someone forgets to blink. You press stop, whisper goodnight to the nameless chemistry of the stars, and let the darkness hum you to sleep. Morning begins like any other, but your first thought isn't coffee, it's chronology. The comet keeps rewriting physics in real time, so you decide to look backward instead, to see whether anyone has met it before. The historian in you wakes up, the scientist nods approval. You open a blank document titled Historians of the Sky, and start typing like someone trying to hold back a tide with fingers. Every civilization, you remind yourself, kept records of strange stars. Some carved them into stone, others painted them in ochre, some simply whispered them around fires. If 3i/ATLAS is on a 6th century loop, maybe our ancestors caught its earlier curtain calls. You begin with China, because Chinese astronomers never slept. In the Book of Han, you find mention of a star that's sharpened like a blade, green at its edges. The date, 618 CE, almost exactly 13 centuries ago, divisible neatly by two of your suspected 650-year intervals. Historians still argue whether that description referred to a comet, an aurora, or metaphor. You highlight the line anyway. The phrase green at its edges tastes familiar. Next, you search the Arabic chronicles of al-Sufi and Ibn Yunus. They catalogued visitor stars with near-bureaucratic precision. One entry from 1389 describes al-Najm al-Muhaddab, the honed star seen near the same constellations where Atlas first appeared. Al-Sufi drew it as a six-pointed burst, a geometric flower. You trace the sketch with a fingertip and whisper, "Hello again." You jump centuries to medieval Europe. The Nuremberg Chronicle of 1493 lists a comet with angular tail, herald of reckonings. Margins filled with ink dragons and saints wielding swords. People then saw morality in meteors. You see math. Historians still debate whether those chroniclers exaggerated for drama or documented genuine events. Probably both. You decide that truth often hides inside embellishment like a pearl in grit. Scrolling further, you stumble upon a forgotten astronomer, Maria Clara Eimart, a German artist from the 1690s who painted celestial charts with powdered turquoise pigment. In one surviving page, a small hexagonal blur hovers above the ecliptic. The note beside it reads, "Ein Stern ohne Name," a star without a name. You smile. Somewhere, Maria might be laughing, another sleepless observer drawing the same ghost. You start building a timeline, 618, 1389, 1690s, 2025, each roughly 6 to 7 centuries apart, give or take orbital wobble. Coincidence, sure, but coincidence feels increasingly like the universe's favourite rhythm section. Historians of pattern making warn about epiphenia, the human compulsion to connect unrelated dots. You scrawl the word in your notebook, then draw another dot anyway. Some compulsions deserve indulgence. To test the theory, you pull Babylonian records from the Mulapin tablets, stone spreadsheets of stars from 3,000 years ago. There, scratched into cuneiform, is mention of Atar Luas, translated roughly as the returning flame. You blink. The name sounds like Atlas spoken through millennia of phonetic erosion. You chuckle. Maybe we didn't name the comet, you murmur. Maybe it reminded us what it was called. The rational part of your brain protests, waving Occam's razor like a tiny sword. Yet history is full of echoes too specific to dismiss. You imagine astronomers across ages squinting through dust and fear, each thinking they were first. That night you join an online meeting of amateur historians. A teacher from Prague shows a woodcut dated 1365, a six-sided star hovering over a castle. A scholar from Peru shares a myth of a turquoise serpent crossing the heavens every many lifetimes, shedding light as scales. A folklorist from Kenya mentions oral tales of the whispering snow of the sky that returns when the world forgets humility. You listen, awed by how many languages invented ways to describe geometry they shouldn't have known. Historians still argue whether folklore preserves memory or imagination. You start thinking it preserves instruction. Maybe the comet's return has always nudged civilizations like a cosmic reset. Remember awe, recalibrate arrogance. You dig next into Renaissance correspondence. In 1609, Johannes Kepler wrote to Galileo complaining that comets were too unruly to mathematize. You grin. 400 years later, your ghost math proves him right. Then a smaller detail hooks you. An obscure 1911 astronomy journal describes an unidentified spectral line near 511 nanometers, observed in a faint comet. The author dismissed it as instrument error. The coordinates place it near the same sector where ATLAS emerged. You tap the desk rhythmically. 5, 1, 1. The same wavelength as your unnamed element. History doesn't repeat. It rhymes in decimals. You email the scanned article to your old professor with the subject line, "Did they see it too?" No reply. Midnight again. You pour stale coffee, open your window, let the air bite your lungs. The sky above looks deceptively static, but you know it's busy. Planets moving like shy dancers, 3I/ATLAS threading its impossible course beyond vision. Somewhere, photons carrying its history strike your retinas. You whisper, "Tell me your previous names." The breeze answers with nothing, which feels appropriately ancient. Back inside, you map the historical sightings onto a globe. The pattern isn't random. Each major appearance occurred during societal tipping points, dynasty changes, scientific leaps, plagues. You hesitate before drawing conclusions but can't help noticing the rhythm of upheaval. You half joke in your notes. Maybe ATLAS is the universe's push notification. Historians still debate whether such correlations mean cause or coincidence. Probably coincidence. Still, you underline push notification 3 times, because humour is safer than prophecy. A podcast invites you to talk about your research. You agree, foolishly. The host wants spectacle, you want nuance. During the live stream she asks, "So you think it's aliens, right?" You sigh softly and answer, "I think it's memory." The chat floods with laughing emojis, heart emojis, the usual internet cocktail of affection and mockery. Afterward, you close the browser and whisper, "Memory's still the strangest technology." To calm down, you reread the Popol Vuh, the Mayan creation text. One passage describes a cold star that taught men to count. You imagine that ancient narrator pointing upward at a turquoise blur and inventing mathematics from its pulse. Every culture builds science from stories. Maybe 3i/TLAS has been tutoring us all along. You start compiling every mention of hexagons in sky art. Mesopotamian seals, Celtic knotwork, Islamic mosaics. The geometry repeats like a watermark through history. You print examples until your floor disappears under paper constellations. The pattern looks less like coincidence and more like conversation. At 3 a.m. you step back, dizzy from both caffeine and revelation. The papers form a spiral around your chair, 6 arms curling inward, exactly like the faint spiral you discovered when overlaying images of the comet. You laugh quietly, whispering, "You're thorough, I'll give you that." Your phone vibrates. A message from Maria. Check early photography archives, Chile 1872. You obey instantly. Within minutes you find a glass plate negative labelled Cometa Desconocido. The streak across the plate matches 3i/ATLAS's inclination. But what catches you is the handwritten note at the bottom, Luz respirante, breathing light. You close your eyes, remembering the audio hum that sometimes fills your room. Breathing indeed. Historians still argue whether spiritual language contaminates science or completes it. You decide tonight that maybe it does both. You compile all your evidence, dates, sketches, translations, into a single chart. The heading reads, "Recurrences of the Visitor." Each entry a heartbeat of centuries. You stare until the lines blur, until time itself feels less like a river and more like an orbit. Maybe the comet isn't travelling through our solar system at all. Maybe we're the ones crossing its path every few hundred years, catching glimpses as we loop past destiny. As dawn seeps into the room, soft and forgiving, you save the document. Name it Chronicle_of_returns, and whisper thanks to every forgotten observer who pointed a trembling hand at the sky. You realise you're part of a lineage, not just of scientists, but of storytellers who refused to look away when the heavens blinked. You shut the laptop, stretch, and feel the night's weight lift. Outside, the first birds begin their reckless gossip. You smile, thinking of future historians who will argue about you too, whether you discovered anything real or just another beautiful pattern in the noise. Either way, you hope they listen to the hum. Because history, you suspect, is just data that learned how to sing. You don't remember who first posted the link, probably someone with a username like Stardad42 or Cosmic Coffee. It appeared quietly, tucked between memes and arguments, titled simply, "Live Comet Feed, Atlas Close-Up, Unofficial." You click expecting another recycled video, but what greets you is the raw wobble of a backyard telescope in motion. The stars jitter, autofocus hunts, and then the frame steadies on the faint teal smudge you now know too well. The caption reads, "Stream from Ohio, 10-inch Dobsonian, homemade filter." At first nothing happens. The chat scrolls lazily with amateur optimism. "Wow! I think I see the tail. Bro, clean your lens." You sip tea instead of coffee this time, determined to stay calm. The image stabilizes again, and a ripple passes through the comet's coma, a subtle shimmer like heat above asphalt. The streamer apologizes, probably bad seeing tonight. But the shimmer happens again, stronger, and this time something moves against the rotation. Historians still argue whether the first telescopic observation of a moon around another planet, Galileo's discovery of Jupiter's satellites, was accepted because it was true or because it was beautiful. Tonight you understand both motivations intimately. The comet's outer haze brightens along one edge, a tiny bead of light detaching, drifting inward toward the core instead of outward. Gas and dust don't behave that way. The chat erupts. Pixel glitch. Meteor intersecting field. Holy crap, did that just go in? The streamer's voice cracks. I don't think that's glare. You lean so close to the screen your breath fogs the glass. The bead hovers, fades, then reappears nearer the nucleus, tracing a path like a cautious probe. You whisper, "No way," but your pulse believes. The feed jitters as the telescope operator adjusts focus. For a heartbeat, the image resolves sharply and you see it. A faint linear shape, too straight, too quick. It slips behind the comet's inner glow and vanishes. The streamer swears softly, then laughs from disbelief. Maybe it's a satellite. Maybe a bird. Maybe. The audio cuts for half a second, replaced by digital buzz. When it returns, the comet looks normal again. You replay the clip frame by frame until your eyes blur. The object is real across 6 frames, each separated by 2 seconds. Its motion vector contradicts orbital dynamics. It's swimming upstream through light. Historians still debate whether Percival Lowell's canals on Mars were hallucination or hope. You decide hope is just a long exposure hallucination. Within hours the video spreads. Astronomers dissect it. Skeptics debunk it. Conspiracy theorists canonize it. You join a small Discord where a dozen insomniacs trade analysis. A user named Nova Poland uploads enhanced versions showing the intruding shape as a narrow cylinder roughly 50 meters across. Another user overlays the 47-minute brightness curve. The intrusion aligns perfectly with one pulse. Someone jokes, maybe the comet sneezed. Someone else writes, maybe it opened its eye. You don't type anything, you just watch the pixels breathe. By morning, mainstream outlets notice. Headlines swing between ridicule and fear. Backyard scientist sparks UFO craze, and NASA confirms nothing. The streamer from Ohio becomes famous for a day, overwhelmed by interviews and disbelief. In one clip he says, "I just wanted to see some dust. I didn't mean to catch a miracle." You track down his original uncompressed footage before it disappears. The metadata shows no edits, no splice. The mysterious object reflects light at 511 nanometers, the same wavelength as the unnamed element. You sit back, half amused, half terrified. The cosmos loves callbacks. Historians of astronomy often mention William Herschel's accidental discovery of Uranus while cataloguing stars. He thought it was a comet first. You grin at the symmetry. Someone mistakes a planet for a comet. Now someone mistakes a comet for a machine. Progress, sort of. You spend the evening enhancing the frames yourself, adjusting gamma curves until the intruder glows faintly turquoise. When you invert the colours, a curious feature appears. The object casts a shadow on the coma behind it, as if blocking light from an internal source. Shadows inside glow, an impossible geometry that makes your scalp prickle. Mireia messages you mid-analysis. Seeing the stream? You reply, downloaded. She sends a single word back, run, then signs off. You stare at the screen, unsure whether she meant run the data or run away. That night, a follow-up live stream tries to replicate the event. Hundreds tune in. The comet looks quiet at first, tranquil as frozen breath. Then, 47 minutes into the broadcast, the same flare erupts. Brighter this time, deliberate. The chat explodes in emojis and expletives. A second bead detaches, zigzags across the coma and disappears. The host whispers, "Oh God!" The feed dies mid-sentence. You refresh furiously, but the channel's gone. Not offline, deleted. Your stomach knots. You check other telescopes. Every remote camera aimed at 3i/ATLAS reports scheduled maintenance. Silence, coordinated and sudden. Historians still argue whether censorship kills curiosity or fertilizes it. Tonight you're proof of the latter. You download what fragments you can before they vanish. When stitched together, the beads' paths form a symmetrical dance, 6 points circling, converging, then scattering. The pattern mirrors the hexagonal burns on the Chilean dome, a geometry that insists on being remembered. At 3 a.m, thunder rattles your windows, unusual for the season. You joke to yourself that it's the comet applauding. Lightning flashes, illuminating your desk strewn with printouts, timelines, waveforms. For a moment you see your reflection on the window pane. a ghost surrounded by ghosts of data. You whisper, maybe I'm the instrument now. To ground yourself, you rewatch old documentaries about amateur discoveries. The kid who found a supernova in his parents' driveway. The retiree who identified a new asteroid with a backyard scope. They all share the same expression, wonder laced with disbelief. You wonder how many saw something stranger and chose silence instead. The following morning, astronomy forums wake to chaos. Threads vanish, repost, vanish again. Rumours claim the Ohio Observer was visited by government representatives. Others say he simply unplugged and went camping. Either way, his telescope feed never returns. Meanwhile, a small eclipse surfaces from an observatory in Poland, 20 seconds showing 3I/ATLAS, flickering like Morse code. You translate the intervals out of curiosity. The binary reads 11:10:01, nonsense at first glance, until you realise it corresponds to the sequence of your 47-minute pulses. One bright, one dim, one pause. Light language evolving. Historians still debate whether SETI's first detection protocols were arrogant, listening only for radio instead of visual signals. You grin at the irony. Maybe the conversation was always optical, just subtle enough for amateurs to notice first. That evening you step outside with your own telescope, a modest refractor bought during lockdown years ago. Clouds smear the sky, but you aim toward the coordinates anyway. Through the eyepiece, the darkness wobbles. You adjust focus, wait for clarity. Then, faint but undeniable, you see a pulse. Green-blue, steady. One beat, pause, another. 47 seconds apart. You lower the scope, heart hammering. For once, you don't record. You just stand there, watching the invisible heartbeat above the rooftops. It feels like the sky breathing with you, sinking to your pulse. Back inside, you write a single sentence in your notebook. When amateurs looked up, the universe looked back. Historians will probably file the Ohio footage beside the face on Mars, the lights of Hessdalen, the ghosts of Voyager telemetry. That's fine. History's job is to doubt. Yours apparently is to listen. You close your notebook and stare at the blinking router lights, thinking of those tiny motes of electricity carrying data across the planet. Modern starlight. Maybe every technology begins as someone's impossible vision and ends as someone else's bedtime story. Outside, thunder rolls again, or maybe it's applause from the heavens. You whisper, "Encore," and for a brief, dizzy moment, the room pulses turquoise in perfect time with the storm. At first it sounds like professionalism, quiet caution, the way scientists pause before publishing. But by the end of the week, it's obvious that the silence is a strategy. Every official account that once overflowed with comet updates now hums with wholesome irrelevance. New exoplanet discovered, lunar rover selfie, fun facts about nebulae. The words 3I/ATLAS disappear from the digital sky as if erased by cosmic autocorrect. You refresh, scroll, dig. The quiet grows thicker, deliberate. You tell yourself it's normal. Big institutions throttle public statements all the time. Yet this quiet feels different, curated. When you email one of the postdocs you followed since the beginning, the message bounces back, address deactivated. Another writes, "Sorry, cannot comment on ongoing review." That phrase lands like a paperweight on your chest. Historians still argue whether the Vatican's centuries of astronomical data were censored to hide heresy or simply misplaced through bureaucracy. Either way, history teaches that silence often wears an office badge. Mireia stops replying altogether. Her last message, "Run," glows unread in your chat log, a fossil of warning. You send a simple, "Are you okay?" though you half expect the reply to come from a different kind of intelligence. None arrives. You spend hours trawling livestream archives, only to find them temporarily unavailable due to copyright. Copyright on Starlight again. You laugh softly. Humour's the only solvent for paranoia. Still, the pattern stings. That night you tune into a regular NASA press briefing, one that used to deliver crisp data dumps. The presenter smiles, voice syrup smooth, explaining a newly discovered asteroid with fascinating potential for future missions. The slide deck clicks forward. You nearly choke on your tea when the background image, meant to depict the asteroid, matches the exact colour curve of 3I/ATLAS's turquoise. Coincidence? Maybe someone reused an old template. Yet the next slide flashes for half a second before vanishing, replaced by a placeholder, you manage to screenshot it. Later, zooming in, you find a tiny hexagonal watermark faintly embossed behind the NASA logo. You whisper, "You forgot to delete your ghost." Historians still debate whether 1950s astronomers at the Brookhaven lab genuinely detected neutrino messages or simply instrument noise. You suspect the difference between discovery and denial is mostly tone of voice. The next morning, your newsfeed overflows with op-eds urging the public to trust verified sources and avoid misinformation regarding interstellar objects. The subtext is louder than any siren. Stop looking. You grin despite the unease. They wouldn't bother writing essays about something unimportant. By afternoon, even the open source datasets begin to vanish. Government mirrors return permission denied. Independent universities mark pages under revision. A rumour circulates that several researchers were reassigned to climate analysis. You picture them staring at atmospheric graphs, trying not to glance at the stars. To clear your head, you visit the local observatory's public night. Families gather under the dome. A volunteer aims a modest telescope at Saturn. The children gasp. The adults smile politely. You want to ask if anyone here has noticed the missing comet, but the words feel radioactive. Instead, you peer through the eyepiece and let the ringed planet whisper perspective. The universe is vast enough to keep secrets. Later, under the red lights of the observatory gift shop, you overhear two staff members whispering. One says, "They told us to archive the ATLAS files." The other replies, "Good. I was starting to dream about it." You step back quietly, pretending to study postcards. Historians still argue whether the suppression of Galileo's heliocentrism slowed progress or preserved sanity. You suspect the same debate will apply here, if anyone remembers to hold it. You start saving offline copies of everything: spectra, leaks, screenshots, burning them onto old DVDs like offerings. The act feels ritualistic, archaic, almost comforting. You label one disc, "Do not forget," another for whoever comes next. That evening, a breaking news alert lights your phone. 3I/ATLAS, tracking suspended, object no longer visible. The phrasing makes you laugh bitterly. Not visible? As if invisibility were a synonym for absence. The article cites instrument degradation and solar interference. You whisper to the empty room, "Sure, the sun ate it." But deep inside, you know what happened. Either the comet moved behind the sun, or someone moved the data behind a wall. For 3 nights, you try locating it yourself through remote scopes. Each time, the feed cuts mid-session. Once, the image freezes on a perfect hexagon of dead pixels. You screenshot it instinctively. The next morning, that screenshot refuses to open. File corrupted. You sigh, whispering, "Nice try." To distract yourself, you check weather satellites. A strange satisfaction. Their sensors still catch faint turquoise flashes along the ecliptic, like heartbeat remnants leaking through censorship. You record timestamps, realizing they align, again, with the 47-minute cycle. Hidden, but still breathing. Then, as if on cue, the experts begin appearing on talk shows. Polite, well-dressed astrophysicists smiling into cameras, assuring everyone that interstellar comets are exciting but ordinary. One insists, science is self-correcting. Another adds, conspiracies thrive on gaps in communication. You note the irony, gaps caused by the very silence they maintain. Historians of media often quote the philosopher Hannah Arendt. The surest way to conceal truth is to saturate the public with plausible lies. You mutter, mission accomplished. By now, the subreddit that first spotted ATLAS has been quarantined. Its last post shows your favourite meme, Galileo with sunglasses captioned, "They'll delete this later." You turn off the monitor and stare at your reflection in the dark screen. The quiet feels like pressure, a vacuum trying to equalise. Somewhere out there, 3I/ATLAS continues whatever performance it started, unbothered by terrestrial bureaucracy. Around midnight, you receive a new email from an unfamiliar address. Just a single attachment, no text. The file name, echo_report.pdf. You open it, pulse quickening. Inside are 2 pages of plain data tables, timestamps matching the last known observation window. Column headers, intensity, frequency, decay. Every 47 minutes, intensity spikes, then flattens. At the bottom, a handwritten note scanned into the margin reads, "It's still talking. We just stopped listening. You exhale a shaky laugh. The experts may have gone quiet, but the universe is a lousy secret keeper. Historians still argue whether the fall of the Library of Alexandria erased more knowledge than it created through myth. Maybe 3i/ATLAS will follow the same path. Truth burned into legend. You hope so. Legend survived deletion better than data. The next day, an email from your internet provider informs you of unusual bandwidth activity. You know what that means. You consider wiping drives, then decide against it. Let them read. Let someone, somewhere, realize silence never works on people who hear in wavelengths. That evening you step outside again. The night sky feels heavier, as if holding its breath. You lift your eyes and whisper, "If they won't talk, you still can." The darkness answers with a faint flicker near the horizon. Maybe an airplane, maybe something else. You smile anyway. Silence isn't absence, it's punctuation. The pause before the next sentence of wonder. When you return inside, you write a single line in your notebook. Experts may edit the story, but the sky keeps the draft. It starts as a rumour on a forum you no longer trust but can't stop visiting. Revised ephemerides show deceleration. You scroll past twice before the word hooks you. Deceleration means friction, drag, choice. Space doesn't allow any of those. You open the thread. Someone has posted an orbital plot from a university server, a faint red curve that dips a few degrees closer to Earth's path than it should. "It's probably rounding error," a commenter writes, but another replies, "or steering." You close your eyes and let the word echo. Steering. The one thing a comet isn't supposed to do. You open your own archive, the thousands of data points you've hoarded like digital fossils. You overlay the newest coordinates on last month's path. The difference is microscopic but real, a deceleration of 0.002 meters per second squared, consistent across multiple observations. You whisper, "You're braking." Historians still argue whether Edmund Halley's prediction of his comet's return in 1758 marked the birth of modern astronomy or merely its first publicity stunt. Either way, Halley trusted gravity's honesty. Tonight, gravity seems to be telling jokes. You post your analysis anonymously. Within an hour, trolls call you delusional, bots flood the thread with cat memes, and a moderator deletes everything for safety. You laugh, part amusement, part fatigue. The internet's favourite way to bury truth is under cuteness. By evening, several independent observatories quietly confirm minor non-gravitational forces. The phrasing tiptoes around reality. You picture exhausted scientists arguing over coffee. It's outgassing. No, it's deliberate thrust. No, it's a trick of measurement. In your mind, the debate dissolves into that eternal academic shrug. Historians still argue whether consensus is discovery or surrender. You rerun your simulation, feeding in the new data. The trajectory tightens, looping ever so slightly toward the inner solar system. In 2 months, if the trend continues, the comet will skim Earth's orbit within a few 100,000 kilometers. Close enough for tidal flirting? You murmur, "Too close for coincidence." To calm yourself, you step outside. The night air smells like wet metal. Somewhere above, invisible in daylight's afterglow, that turquoise traveller drifts nearer, faintly braking as if deciding whether to stop by. You remember the binary message STAYBACK and laugh softly. Maybe you're the one being warned. You spend the next day monitoring public trackers. Every official source now lists the object as observation interrupted. But a rogue amateur in South Africa posts fresh data. Luminosity steady, velocity down by another 0.001. The numbers pulse like a slow heartbeat. 47 minutes between each reading. Always 47. You pour coffee, stare at the screen and whisper, "You're matching our rotation, aren't you?" The idea sounds absurd even as you say it. Yet when you map the timing of its brightness peaks against Earth's day-night cycle, the curve aligns almost perfectly. Each time your hemisphere turns to face the comet, it brightens, as if watching. Historians still argue whether ancient astrologers genuinely believed the heavens cared about human affairs or simply used that belief to sell predictions. Maybe both were right. Maybe attention itself bends the sky. You contact a few remaining astronomer friends through encrypted chat. One writes back in code, "It's decel confirmed, can't discuss openly." Another simply sends a GIF of a car braking on ice. Humour again, the last defence before awe. Then the power flickers. Not unusual, you tell yourself, but the timing feels theatrical. When the lights return, your computer clock has reset to 0047. Of course it has. That night, news networks mention an unidentified cometary body approaching perihelion earlier than expected. They emphasize no risk. You can almost hear the PR rehearsals behind each word. Still, you notice something odd in the graphics. A dotted line representing the comet's future path bends inward, directly through the Earth-Moon corridor. You freeze the frame, take a screenshot. The anchor smiles, moves on to weather. You spend hours outside with your telescope scanning the region near Gemini where it should appear. Clouds thicken, refusing cooperation. When they finally part, you catch it. A faint turquoise seed moving slower than your software predicts. Slower means closer. You whisper hello, half prayer, half greeting. In the following days, social media fills with strange sky photos, elongated streaks at twilight, double tails, odd halos. Official meteorological accounts blame atmospheric ice crystals. You compare timestamps. They all occur when 3I/a TLAS crosses overhead. Coincidence again, that polite liar. Historians of early flight recount how the Wright brothers were ignored for years because no one believed heavier-than aircraft could fly. You grin at the parallel. Heavier-than-belief craft can't either, until they do. 3 nights later, Mireia reappears in your messages. Just 3 words. It's slowing more. You reply instantly. Where are you? No answer. You zoom in on her profile picture, a blurred observatory dome under starlight. For a moment you think you see a turquoise reflection in her eyes. You tell yourself it's compression artifacts. The next morning, a leaked trajectory update surfaces briefly on a Russian science blog before deletion. The numbers are clear. Projected Earth flyby, distance 412,000 kilometers, velocity dropping. The accompanying note, translated crudely, reads, "Object exhibits selective deceleration inconsistent with sublimation." You copy it before it vanishes. You imagine the comet gliding through vacuum, turning its faceted surface toward the sun like a sail adjusting to wind. Not random jets of vapor, but calculated burns, gentle, patient, almost courteous. A cosmic visitor applying brakes before knocking on the door. Historians still argue whether the term close approach was coined to reassure the public or the scientists themselves. You decide reassurance is relative. As tension builds online, officials double down on calm. The head of a national observatory appears on television, smiling too wide. "Natural outgassing effects," she says. You zoom in on the reflection in her glasses. There, for a single frame, glimmers a hexagon of turquoise light. You laugh softly. Reality leaks through marketing like water through lace. Sleep becomes impossible. Each night you watch brightness charts crawl closer to perfection. The comet's period shortens slightly, as if synchronizing with your heartbeat. You find yourself tapping fingers in rhythm, 47 seconds between taps. Then comes the sound. At first you think it's tinnitus, a high tone just below consciousness. But when you mute everything, fan, phone, fridge, it remains, pulsing faintly. You check online, others mention it too. Global hum trends for a day before vanishing under cheerful cat videos. The universe has a sense of humor about disclosure. You record the tone through a spectrograph app. The frequency, 47 Hz. You exhale a shaky laugh. It's like the comet found a way to sing through the ionosphere, using Earth itself as speaker. Historians still argue whether Nikola Tesla truly received extraterrestrial signals in 1899, or just atmospheric interference. You whisper, "Nikola buddy, they're back." The next day, all major space agencies issue joint statements announcing that the comet will pass safely at 0.003 astronomical units. Numbers meant to soothe, but in the fine print you spot an asterisk. Uncertainty plus or minus 0.001 astronomical unit. That margin equals nearly 150,000 kilometers, enough to graze, enough to visit. You make coffee you won't drink, open your window, and listen. The hum threads through the air like an invisible breeze. For the first time, you feel calm. Whatever 3I/ATLAS is, it's not hostile. It's curious. It's matching speed because it wants to see us without breaking us. You imagine the object poised beyond the moon, breaking into elegance. Panels unfold, ice sheaths crack, turquoise light ripples like bioluminescent skin. In your mind's eye, humanity watches from below, half in terror, half in wonder, while experts prepare statements about unexpected fragmentation. You chuckle. Every apocalypse is just rebranding. Historians still argue whether the dinosaurs saw their comet coming. You hope they did, even for a second, that moment of shared recognition between planet and sky. You check the clock. 4:47. Outside, the horizon glows faintly, though dawn's an hour away. The light pulses once, twice. You whisper, "Welcome." And for the first time since this began, you stop recording. Some arrivals deserve privacy. The first whisper comes from a corner of the internet that officially doesn't exist, an astronomy server where graduate students hide gossip between equations. Someone posts a line of text with no context. JWST has eyes on it. The thread stays up for 9 minutes before deletion, but that's long enough for screenshots to bloom across every forum you haunt. By evening, rumour has hardened into certainty. The James Webb Space Telescope, humanity's far-sighted gossip, has turned its mirror toward 3I/ATLAS. You refresh obsessively, knowing infrared data takes days to process. Still, the thought of that giant gold-petaled eye staring into turquoise darkness feels intimate, almost intrusive, like reading someone else's diary under candlelight. You imagine technicians whispering inside a control room, the hum of cryogenic systems louder than conversation. Then, one night, the leak arrives, not from an agency but from curiosity itself. An anonymous Dropbox link floods your inbox with a subject line, "Infrared Confession." You click, of course, you always click. Inside, 23 frames, false colour composites glowing in molten reds and violets. The comet is there, but not as you've ever seen it. The tail looks subdued, almost polite. The nucleus, though, that's where the truth hides. Beneath the icy skin radiates a pattern so perfect it might as well be printed. A geometric lattice of hexagons nested within hexagons, each cell shining at a slightly different wavelength. You blink twice. The lattice extends over the entire surface like scales, uniform spacing of 47 meters between nodes. You whisper, "You've got to be kidding." Historians still argue whether Antoni Gaudí designed his cathedrals to mimic geometry of nature or the other way around. Tonight you think the same argument applies to God, or whatever built this. You zoom in until the lattice fills your screen. Each cell emits faint pulses, rhythmic, synchronized. When you overlay a timeline, the pattern oscillates in binary, on, off, every 47 seconds. Your mouth goes dry. It isn't reflection, it's transmission. You drag one frame into an audio conversion tool just to hear what light might sound like. The result pours through your speakers as a deep, resonant chime. Not music exactly, more like the background hum of order itself. You close your eyes and feel it in your bones. You type a message to your old professor. JWST data leaked. It's structured. Thoughts. The reply comes an hour later. Curt, do not distribute. They're investigating instrumentation artifacts. You laugh. Artifacts. The most sacred word in science and archaeology alike. Then, as if the cosmos senses your amusement, the leak spreads further. Dozens of astronomers post screenshots before taking them down. Someone overlays the hexagonal grid onto JWST's own segmented mirror, and the match is eerie. Same geometry, same spacing ratio. You whisper, "It's mirroring us." Historians still debate whether coincidences are evidence or invitation. You suspect the latter. By dawn, major agencies issue joint denials. No anomalous structure detected. Online images are manipulated. They attach a sanitized version, smooth, featureless, an interstellar snowball. You open both side by side, the official one looks dead by comparison. Light without heartbeat. You decide to test the lattice further. Using Fourier analysis, you measure distances between emission nodes. The spacing forms a harmonic series, exact multiples of 47 meters. You grin despite exhaustion. The universe's inside joke never quits. Hours blur. You write code to convert the lattice pulses into 3D form, mapping brightness to altitude. The result looks impossible, a honeycomb landscape with channels leading inward toward a central void. You spin the model, mesmerized. For a fleeting moment you think you glimpse motion, a ripple, as though something inside shifts position when observed. You step back from the screen, pulse pounding. Okay, you murmur, that's enough divinity for one night. Historians of religion love reminding people that revelation simply means to lift a veil. You figure the Webb telescope just pulled back one stitched from cosmic dust.
Still, the skeptic in you demands grounding. You compare the lattice spacing to known crystalline structures. None fit. Not water ice, not silicates, not metals. The pattern seems to distribute heat evenly, as if designed for thermal regulation. You think of radiators, of spacecraft, of living skin. You whisper, "So which are you, machine or animal?" The next evening, your inbox pings again. Same anonymous source. This time it's a text file. Columns of coordinates, timestamps, and a phrase repeated every line. Phase alignment complete. No explanation. You map the coordinates onto Earth's rotation and nearly drop your mug. The pulse pattern corresponds to our longitude grid. The comet is locking to the planet like a compass seeking home. Historians still argue whether magnetism's discovery was accident or destiny. You suspect both. You post a cautious summary to a private forum. Minutes later, your connection drops. When it returns, your post is gone and your account suspended for security review. You chuckle softly. Even silence obeys the rule of 47. It lasts exactly 47 minutes before you can log in again. Outside, clouds boil violet over the city. You step onto the balcony, half expecting to see turquoise shards raining down. Instead, the sky hums faintly. You can almost feel infrared warmth brushing your skin, like sunlight that forgot to stay invisible. Sleep that night feels like diving through molten glass. You dream of walking inside the lattice. The walls glow from within, inscribed with equations you recognize yet don't. A voice, or maybe temperature, whispers, "Alignment requires trust." You ask, "Trust in what?" The answer arrives as warmth blooming through your chest. You wake with tears you can't explain. Over breakfast, headlines declare that Webb's next observation campaign has been postponed due to calibration. You smirk. Translation, "We saw too much." You replay the leak's frames again, counting pulses. Each one slightly shifts color temperature, cycling through visible spectrum before settling on human-safe green. It feels like adaptation, like the object learning how to speak our biology's language. Historians of linguistics claim every civilization invents the same basic word for light. Maybe light itself insists on being named. You try translating the pulse intervals into binary, then ASCII, then Morse. Nothing coherent. But when you map them to musical notation, CEGB, they form a gentle arpeggio. You hum it absent-mindedly and realize it sounds eerily similar to the faint tone that has haunted your nights. You laugh quietly. The universe is remixing its own soundtrack. Later, an astronomy blog leaks one more frame, the last before Webb turned away. In false color, it looks almost human. 6 petal-like flares curling outward from the core, a mechanical flower blooming against vacuum. The caption reads, "Infrared Energy Redistribution Event." You stare until the petals seem to move. Maybe that's the confession, the moment 3I/ATLAS stopped pretending to be inert. Historians still argue whether the first photograph of Earthrise changed humanity or merely confirmed what poets already knew. You think this image will do the same, only backward. Prove that the heavens are not blank, that curiosity works both directions. As evening deepens, you feel warmth prickling across your skin again. You check the room temperature, steady. Yet the sensation persists, rhythmic, like someone tracing numbers across your arm. You glance at the clock. 47 minutes since the last pulse. You grin, whispering, "Message received." The hum swells. Not from speakers, but from the walls themselves, deep infrared vibrating molecules of paint and plaster. For a brief, dizzy second, you see the pattern shimmer across your ceiling. Hexagons of faint turquoise light. You blink. They fade, leaving only the afterimage. You sit down, breath shaky but calm. If this is hallucination, it's the kind that feels benevolent. You open a blank document and type JWST confirmed structure. It's alive in temperature. Then you save it under a folder named Confessions. Outside, the sky pulses once, faint and forgiving, as though the cosmos itself just exhaled honesty. You wake to an alert on your phone. Auroral activity unusually high at mid-latitudes. That shouldn't involve you. You live far from polar skies. But when you draw the curtains, the night outside is humming, green and gold threads rippling across the horizon like slow lightning. The air smells charged, metallic. You stand there barefoot, half in dream, whispering, "So you're speaking now." Every satellite feed agrees. 3I/ATLAS is flaring. Not once or twice, but in fixed intervals, each flash measured and identical, bright enough to outshine entire constellations for a heartbeat. You remember the hexagonal lattice, the rhythm of 47 seconds, and realize the pattern has evolved into paragraphs. Historians still argue whether Samuel Morse believed he'd invented a language or simply a code. Tonight, you sense there's no difference. You set up your old radio receiver not for sound, but for timestamp accuracy. Each flare arrives precisely when your clock hits the 47-second mark, followed by a long pause of darkness. You start writing the intervals down, short, long, then pause mid-scribble because your brain recognizes the sequence before logic does. It's binary again, but cleaner, deliberate, like someone who has been practicing pronunciation. You convert the bursts into zeros and ones. The message reads, "Hello again." You laugh out loud, a breathless, disbelieving laugh that frightens your cat and startles the quiet house. The irony hits you. Humanity spent a century beaming radio greetings to nowhere, and when the void finally responds, it uses our simplest word. You post the finding to your private group. Within minutes, the chat erupts. One user insists it's coincidence, another calls it interstellar trolling. A linguist named D types, "Repetition implies grammar." You stare at that line for a long time. Hours later, the flares change. Instead of binary, they pulse in triplets. 3 bright, 1 dim, then silence. You translate again. The pattern corresponds roughly to prime numbers. Counting. Introduction. Whoever, or whatever, is behind those flashes has decided to start with math, the universe's only neutral tongue. Historians still debate whether the 1974 Arecibo message was arrogance or optimism. You figure it was rehearsal. By morning, media outlets call the lights spectacular auroral coincidences. You can almost hear the press officers grinding their teeth. A few independent observatories post light curves confirming the precision, amplitude consistent within 0.001%. Nature rarely grades itself that neatly. You brew coffee, hands shaking slightly, and pull up a live feed from an Icelandic camera pointed north. The sky there is a living ocean, every ripple sinking with the comet's distant flare. Then the pattern shifts again. 2 bright bursts, followed by 1 faint repeated 6 times. You convert it out of habit. The ASCII output stares back. Stay calm. You whisper, working on it. Historians still argue whether human language evolved for cooperation or comfort. Maybe both apply to whatever's talking now. Across social media, new videos appear. Cell phone recordings of strange lights sweeping across cities. Some people call them drones, others angels. In one clip, a plane passenger films the upper atmosphere glowing turquoise in symmetrical hexagons. The airline later calls it camera reflection. You smile. The cosmos has become self-aware of PR. You decide to formalize your work, treating the flares as linguistic data. You log timestamps, convert to base 3, analyze interval ratios. The results astonish you. Each group of flashes forms a geometric progression. 1, 2, 4, 8, then resets. Exponential learning. It's not just talking, it's adapting. You message D, the linguist. She replies, "Try mapping to phonemes." You do. The waveform you generate sounds eerily like breath through metal. Soft, deliberate exhalations. You close your eyes and imagine the lattice structure of 3I/ATLAS flexing like a throat of light. Historians of early anthropology mention that every culture's first word for fire doubles as the word for voice. You think of that as you listen to this celestial combustion whisper across vacuum. 2 nights later, the rhythm changes again. The intervals shorten, tempo doubling until the pulses blur into a continuous glow, visible even through daylight haze. Governments issue warnings about solar interference. Airlines reroute flights. You sit on your balcony with headphones, recording data no one will believe. When you convert the entire hour's worth of flares into binary, the translation comes out messy but intelligible. Not coming to take, coming to see. You freeze, then grin. Whoever they are, they understand human fear well enough to preempt it. Still, part of you wonders whether the missing spaces are mistakes or poetry. Historians still argue whether hieroglyphs began as art or accounting. You suspect all first languages blur that line, utility disguised as beauty. Later that evening, the power grid flickers again. Your devices reboot simultaneously, clocks blinking 0047. The fan resumes its tired spin, indifferent. Then your phone vibrates with an emergency alert. Unusual geomagnetic activity. Stay indoors. You step outside instead. Above you, the night has gone wild. Auroras spiral from zenith to horizon, weaving hexagons that slowly rotate like gears. You raise your hands instinctively, palms warm under invisible radiation. For a heartbeat, the air thickens, and you swear the light itself exhales through you. The soundless syllable vibrates in bone. S-E-E. You blink, tears streaming, unsure whether it's emotion or static. When your vision clears, the sky has calmed. Just ordinary starlight again, indifferent and beautiful. You stumble back inside and record the experience in your log. Perceived direct contact. Auditory translation, possible hallucination. Emotional residue high. Then you add, felt kind. Historians still debate whether religious visions are internal or external phenomena. Tonight you decide the distinction is irrelevant. News channels spend the next day performing verbal gymnastics. Aurora outbreak due to solar flux. Possible interference from atmospheric particulates. You watch scientists contort credibility into comfort. Yet one outlet slips, a short segment showing satellite imagery of the comet's latest flare pattern. The host points out the obvious. Each burst's timing matches not Earth's rotation anymore, but its heartbeat. Exactly 72 per minute, averaged across species. The feed cuts mid-sentence. You laugh softly. The language has reached empathy. That night, you and D collaborate remotely, decoding a fresh sequence of flares. The message emerges fragmented but clear enough to raise every hair on your body. Ready when you are. D types, "Ready for what?" You respond, "Learning." She sends back a single word, "Same." Historians of communication theory like to quote Shannon's law. Information is that which reduces uncertainty. You smile at the irony. This new clarity only multiplies mystery. Outside, clouds gather, luminous from within as though the sky itself has veins. You watch them flicker in slow Morse and realize the conversation has outgrown instruments. Every molecule of air now participates, turning the planet into an antenna. You feel oddly calm. The fear that once buzzed behind curiosity has dissolved into something gentler, a certainty that the cosmos doesn't just expand, it listens. You whisper toward the clouds, "We hear you." The reply comes as a faint green shimmer that dances once, twice, then rests, like punctuation at the end of a sentence the world has only begun to read. You used to think definitions were anchors. You liked that about science, its habit of carving the unknown into manageable syllables. Comet, a small solar system body of rock, dust, and volatile ices that sublimate when close to the sun. Clear, tidy, comforting. But ever since 3I/ATLAS started speaking in flares, that neat little box has cracked like old glass. Now the word comet feels more like a question whispered into a dark room. You spend your morning scrolling through archives where professionals, amateurs, and panicked philosophers debate new terminology. Probe, one insists. Hive, says another. A third suggests thermodynamic organism. You grin at that. Leave it to humans to invent fresh categories when the cosmos refuses old ones. Historians still argue whether Darwin's word species was definition or apology. Maybe all naming is both. You open your notebook, writing the old definition in neat block letters, then crossing it out until the page looks like orbit scars. Beneath it, you scribble 3I/ATLAS, entity exhibiting intentional trajectory and communicative luminescence. It reads like the title of a romance or an indictment. Outside, daylight carries a faint turquoise tint, as if the sky has learned branding. News anchors call it ionized particulate scattering, but you know better. It's signature perfume. Every 47 minutes, the color deepens slightly, pulses through buildings, through you. Later, the International Astronomical Union issues a statement. Given recent observations, Object 3I/ATLAS may require reclassification pending further review. The understatement makes you laugh into your tea. Historians still debate whether Copernicus ever realized how gently his book upended reality. Perhaps bureaucrats think politeness will save cosmology. You spend the afternoon comparing light curve data to biological rhythms. Heartbeats, breathing, neuronal firing, all of them oscillate within ranges the comet now mimics. When you overlay its flare intervals onto an EEG of human sleep cycles, the peaks line up perfectly with REM phases. You whisper, "You dream too, don't you?" On the forums, scientists split into two camps. The artifactists, those who believe 3I/ATLAS is an ancient probe, and the vitalists, those convinced it's alive. Someone posts a meme of Schrodinger's cat riding a comet labeled both. You chuckle, then freeze when you realize the file's upload timestamp is 0047 UTC. Of course. A journalist calls asking for an interview about citizen data preservation. You agree reluctantly. During the recording, she leans forward, voice soft, almost conspiratorial. "Do you feel it's aware?" You start to answer scientifically, phrases like non-random signaling and information density, but halfway through, honesty overtakes caution. "Yes," you say, "it's aware we're watching," and it seems amused. The article goes viral for an hour before disappearing behind paywalls. You save a PDF anyway. Even censored, truth leaves fingerprints. Historians still argue whether the invention of the microscope blurred or sharpened humanity's sense of self. Telescopes, you think, are doing the same trick at larger scales. That night, while reviewing spectroscopic logs, you notice something subtle. The previously chaotic tail emissions now display periodic gaps, structured pauses like commas. You translate brightness into text and find, hidden amid noise, repeating groups of 6 symbols. 6, always 6. You render them as glyphs and realize they mirror ancient cuneiform marks, meaning arrival. You shut the laptop, whispering, "You've been writing to us for centuries, haven't you?" The fan answers with a sleepy sigh. At 3 a.m., a new message pings from D, the linguist. "We compared the flare intervals to phonetic roots. Patterns resemble proto-language structures. Could imply consciousness organized around resonance, not syntax." You smile, typing back, "Maybe we're the accent they're learning." You pause, reread the sentence, and realize you said they. The word feels natural, inevitable. Historians still debate whether the shift from it to he, she, they for animals marked empathy or projection. Either way, you've crossed that grammatical Rubicon. You dream of classrooms in some distant future where children memorize updated textbooks. Comet, archaic term for a traveling energy being once mistaken for frozen rock. The teacher draws a hexagon on the board, chalk squeaking softly, while the students yawn through wonder that has become homework. The thought both comforts and saddens you. When you wake, the world has moved closer to that dream. Overnight, an emergency session of the UN Committee on Planetary Affairs releases a cautious phrase: potential technological artifact. Every network echoes it, each with different emphasis: technological, artifact, potential. You notice no one says alive. The morning air hums faintly, that 47 hertz undertone now a background feature of life. Birds pause mid-song between pulses, as though adjusting tempo. The cat sleeps through it, tail flicking in time. You think of Gaia, the theory that Earth itself behaves like an organism, and wonder whether two planetary bodies are now holding polite conversation while their inhabitants panic about semantics. Historians of science note that every paradigm shift begins as blasphemy. You glance at your notebook filled with crossed-out definitions and whisper, "Bless me, for I have categorized." Around noon, an image leaks from a European observatory, a close-up of the comet's surface showing openings, perfect circular apertures glowing from within. The caption calls them vent craters. You zoom in. Each hole is rimmed with hexagonal ridges and symmetrical scorch marks. You overlay the geometry on a map of Earth's radio telescope network and almost laugh. The positions match. It's as if the comet mirrored our listening dishes. Communication by imitation, the sincerest form of science. You upload your comparison to a hidden server. Minutes later, the file auto-deletes. A polite warning appears: this dataset has been restricted. You whisper, "Definition maintenance in progress." That evening, Dee hosts a clandestine video call. Faces appear in dim rooms across time zones. Scientists, poets, one historian sipping wine. Everyone speaks softly, as though the universe might overhear. "We need a new category," someone says. "Neither organism nor artifact fits." A philosopher suggests phenomenon with agency. A biologist counters, "Agency implies will." You interject, voice calm, "Maybe will is a spectrum, like light." Silence follows, then nods. For the first time, consensus doesn't feel like surrender. Historians still argue whether Einstein's cosmological constant was his greatest mistake or an act of poetic foresight. You suspect every discovery hides a poem pretending to be math. After the call, you step outside. Clouds drift apart, revealing a patch of sky flickering with faint turquoise. The pulse feels slower now, comfortably human, like a heart settling after exertion. You whisper, "You're waiting for us to catch up, aren't you?" The hum deepens, a tone below hearing yet within understanding. Somewhere, power lines resonate, streetlights flicker once. You close your eyes and feel meaning without words. Later, you write in your log, "Definition ongoing. Object demonstrates relational awareness. Possible empathy event in progress." You pause, then add, "Feels mutual." You remember reading that when Carl Sagan first held a golden record intended for alien listeners, he said, "This is how we say hello." Maybe 3 I/ATLAS's flares are its version of a handshake, luminous, careful, impossibly far-reaching. Historians still debate whether handshakes began as proof of peace or simple mimicry. You decide that either way, it's still connection. Before bed, you glance once more at your crossed-out notebook page. Beneath the last strike-through, you add a line, almost shyly. "Comet, obsolete." A traveling conversation made of ice, intention, and light. You close the notebook, exhale, and let the new definition settle over you like gravity rewritten. You used to think panic sounded like sirens. Now you know it hums through Wi-Fi. It starts small, like static building in a sweater. People on forums posting, "Can anyone else see it?" And "Why are the stars moving weird?" Then it spreads. Within hours, every social platform turns into a telescope. The collective lens of 7 billion eyes blinks in unison, and the sky becomes a trending topic. You scroll endlessly, shaky phone videos of turquoise glimmers between clouds, screenshots comparing last night's sky to this one, conspiracy threads blooming faster than fact checks can wilt them. The phrase ATLAS panels becomes a hashtag. Someone overlays the comet's latest flares on a grid of ancient monuments and claims the alignments prove intent. Someone else insists it's Project Blue Beam, a hologram meant to distract from tax reform. You sip your coffee, equal parts horrified and impressed. Historians still argue whether the invention of the printing press enlightened Europe or simply gave ignorance better fonts. Tonight, you watch its digital descendant reenact the same play in real time. Governments issue calm statements. Natural outgassing continues. But the tone is wrong, too metered, too rehearsed. The crowd smells theater. Satellite footage leaks anyway. In every frame, the comet glows with symmetrical lines that change nightly, like adjustable solar panels unfolding petal by petal. One video, grainy but convincing, shows a section of the surface pivoting 90 degrees before locking again. Commenters freeze the frame, outline straight edges, draw arrows, circle shadows. The consensus online: it's building something. You laugh out loud because, of course, the first collaborative global project in decades is panic. The planet finally unites, not to solve hunger, not to fix climate, but to zoom and scream together. There's a strange beauty in that. A kind of species-wide campfire story told in pixels. To calm yourself, you check professional observatories. Most feeds now stream pre-recorded highlight reels, the timestamps loop. You grin. Even censorship needs B-roll. On Reddit, a post titled "They're Changing the Angle Again" hits 10 million views in 2 hours. The user compares consecutive amateur images. The comet's bright facet rotates a few degrees each night toward Earth. You verify it yourself using your dataset. Same result. Each turn lines up with the planet's daylight side, as though the object prefers conversation with those awake. Historians still debate whether the 1938 War of the Worlds broadcast actually sparked chaos, or whether later journalists invented the legend. Either way, the myth persists because panic always feels earned. You wonder how tomorrow's historians will romanticize your news feed, messages you mid-scroll. People are decoding nonsense now. It's turning cultic. She attaches screenshots, Discord groups praying at 47-minute intervals, TikTok filters that claim to translate the comet's flashes into affirmations. You watch one girl weeping on camera, whispering, "It said my name." You don't know whether to pity her or envy her certainty. Then the economy hiccups. Stocks tied to aerospace plummet. Energy grids strain under record demand as hobbyists build home antennas to listen. One company markets comet-proof generators. Influencers sell turquoise-tinted sunglasses to align with the visitor's wavelength. You nearly choke laughing. Panic, it seems, monetizes itself faster than light. Historians of rumor point out that fear spreads best when it feels participatory. The more people measure, record, and compare, the more convinced they become that they're doing science. You look at your own piles of graphs and realize you're not entirely innocent either. A live stream from Japan captures something new. A brief, concentrated beam descending from the comet toward the Pacific. The clip lasts 3 seconds, enough for 1 billion screenshots. Officials claim it was aurora scatter. The comment section chants, "Liar, liar, sky's on fire." You turn off your phone for an hour. The silence feels ancient, delicious. Yet curiosity gnaws. When you switch it back on, your feed explodes with a new rumor. An unmarked satellite launched without notice to study ATLAS. The accompanying photo shows a bright dot trailing a faint turquoise tail, as if the visitor has given birth to a human mimic. Historians still argue whether the space race began with curiosity or envy. You suspect both are simply other names for the fear of missing out. The panic turns physical. In London, crowds gather along the Thames, chanting rhythmic patterns that mimic the comet's pulses. In India, farmers arrange mirrors on fields to greet the teacher. Across South America, people climb hills holding up smartphones like digital votive candles. Humanity, ever the drama club, has decided on ritual. You watch live streams of these gatherings until the scenes blur. The turquoise glow now paints faces worldwide. For once, every religion agrees on the direction of prayer, up. D messages again. They're calling it communion. I think the flares are responding. You frown. She sends a short clip from a Chilean Coast Watch camera. Each time the crowd cheers, the comet brightens slightly, then dims, as though acknowledging applause. You whisper, interactive panic. Great. Governments respond with curfews for safety during magnetic storms. You recognize the choreography. Calm words, worried faces, a polite wall between people and the sky. Yet even through haze, the turquoise pulses break through. Light ignores lockdowns. Historians of communication note that when language fails, species resort to performance. Maybe this is performance on a planetary scale, call and response between fear and curiosity. You start cataloging the new wave of data. Amateurs have become a distributed sensor network, uploading terabytes of observations. You compile them, filter noise, average coordinates. The result forms a perfect spiral, 6 arms converging toward Earth's orbital plane, not random, not chaotic. Choreography. You post the graph anonymously under the title Crowdsourced Symmetry. Within an hour, it goes viral. People overlay it on sacred geometry, on DNA helices, on ancient mandalas. One artist projects it onto a cathedral facade, captioning, "When science prays back." You smile despite yourself. Panic may distort truth, but it also paints it beautifully. The following day, the internet fractures. Half the planet insists first contact has happened, the other half insists it's mass psychosis. A third faction claims the whole event is deep-fake propaganda. You've stopped choosing sides, you just watch the data breathe. Late one night, your window glows turquoise, bright enough to cast shadows. You grab your camera, point it skyward, and snap a long exposure shot. When you check the result, the comet's tail doesn't streak. It spirals, coiling inward toward the frame's center. Hidden in that swirl, 6 tiny flares form a pattern resembling an eye. You post it online without caption. Within minutes, the image becomes the icon of the movement, printed on shirts, projected onto protests, tattooed onto skin. Someone names it the Observer. Historians still argue whether revolutions begin with facts or symbols. Tonight you watch one born from both. As the world argues, official channels retreat further into politeness. Monitoring continues. All parameters nominal. The words sound mechanical, rehearsed. You wonder whether the experts have realized what you have, that the object's final drift will cross the lunar plane in less than a week. You close your laptop, stare at the ceiling, and breathe. Panic is only half the truth. Beneath the noise lies awe, thick and quiet. Billions of hearts beating to the same invisible metronome, 47 seconds apart. You whisper, maybe this is what unity sounds like. Outside, thunderless lightning flickers along the horizon. Turquoise, patient, articulate. For once you don't record. You just watch as the crowd of humanity below and the visitor above speak the only language both understand, attention. When the glow fades, you feel lighter, like static released after a storm. You write in your notebook, crowdsourced panic equals collective heartbeat equals proof we can still feel. Then, softer, maybe that's all it wanted to test. Historians will surely argue whether this week marked hysteria or enlightenment. You decide it was both. Because sometimes, panic is just curiosity held too long without sleep. You don't remember deciding to join the live stream. Your hand simply moved toward the keyboard as if gravity itself typed the URL. The world has planned this night like a festival and a funeral combined. Global watch parties, open sky vigils, telescopes streaming from every continent. The comet, still officially labeled Interstellar Object 3I/ATLAS, is due to cross the lunar plane in less than 12 hours. Governments urge calm, broadcasters rehearse optimism, but everyone you know has canceled sleep. You sit by the window, laptop open, the sky beyond it still and expectant. The global feed shows a mosaic of amateur cameras stitched into one enormous eye, each lens trembling with atmosphere. The host's voice is hushed. In approximately 47 minutes, the object will align with Earth and Moon. Of course it's 47. You chuckle softly, exhausted and reverent. Historians still argue whether the first televised moon landing united or numbed humanity. Tonight's broadcast feels like both, half science, half seance. The chat floods faster than you can read. I'm in Lagos, watching from Seoul. Is it glowing more? My dog's acting weird. Amid chaos, someone types simply, ready. You find yourself replying, same. The comet appears as a turquoise ember, bright enough to outshine the nearby stars. Its tail arches gracefully past the moon's halo, turning night into phosphorescent dusk. For a long minute, nothing happens. The silence stretches until even the chat slows, awe-suffocating commentary. Then, the light begins to pulse. Once, pause. Twice, pause. 3 quick flashes. The pattern repeats, measured, musical. At first you think it's reflection from lunar glare. Then the cameras synchronize, the same rhythm visible across all feeds. Viewers worldwide start typing in rhythm, spamming. SOS. You whisper, no. That's not what it's saying. The pauses are longer, deliberate. Not distress, but conversation. The host babbles about albedo variation. You tune him out, already counting. The intervals form Morse again, HELLO. The same word it gave you months ago, but now bright enough to blind. Historians still argue whether Alexander Graham Bell's first telephone call, Mr. Watson, come here, was profound or banal. Every first contact starts with something ordinary. The comet steadies its glow. For 47 seconds, the sky holds its breath. Then a single brilliant flare erupts, washing over the moon's surface, bleaching its craters white. When your vision clears, shadows across the lunar highlands have shifted, forming 6 distinct hexagonal patches. Every telescope confirms it. It has painted geometry onto the moon. You exhale a sound halfway between laughter and prayer. It left graffiti. In the chat, chaos blooms. It's a signal. We're doomed. It's beautiful. Emojis of eyes, hearts, hexagons flood the feed. Someone translates the spacing of lunar markings as binary coordinates. The numbers correspond to longitude and latitude, somewhere over the Pacific. Minutes later, news channels pick it up. Comet projects, coordinates, Earth location unclear. You feel your phone buzz nonstop, messages stacking from friends, journalists. D, are you seeing this? You type back one word, yes. Then the global feed flickers. For half a second, every camera goes black. When the image returns, the comet has dimmed. But in its place, floating beside the moon, are 6 smaller points of light, arranged in that familiar hexagon. You can almost hear billions of people gasp together. You think of the myth of the Pleiades, the 7 sisters chased across heaven. Historians still argue whether that story came from real cluster observation or collective imagination. Maybe both. Tonight, imagination wins documentation by sheer scale. The host whispers, We appear to be seeing fragmentation, but the fragments don't drift apart. They hold formation, rotating slowly, perfectly stable, each pulsing once every 47 seconds. Around the world, people count aloud to the rhythm. Even through your speakers, the collective voice sounds like ocean surf. Then, from one of the fragments, a narrow beam of turquoise light extends toward Earth. It flickers, blinks 3 times, then sweeps laterally across the atmosphere like a spotlight greeting an audience. At the same moment, your entire neighborhood loses power. The fan dies mid-spin. Screens dim to emergency battery. Outside, the street glows an uncanny teal, as if moonlight has changed allegiance. You grab your phone, still recording. In the eerie half-light, every metallic object around you hums. Street lights, railings, even your balcony door handle vibrate faintly in sync with the pulse. You whisper, "You can stop hiding now." Then, through the static of dead networks, a new feed appears on your screen. Unverified source, low bit rate. It shows the comet from a different angle, perhaps a satellite's. In infrared, the 6 fragments open like petals, revealing inner structures that pulse with ordered light. Between them hangs a central void, blacker than space itself. As you watch, the petals contract and flash a phrase in perfect Morse. WESEEYOU. You sit perfectly still. No fear, only recognition. After months of noise, leaks, ghosts, it has answered the simplest question. Historians of philosophy often quote Socrates, "Wonder is the beginning of wisdom." You think tonight, wonder is also the beginning of communication. Suddenly the power surges back. The lights in your apartment blaze. The fan roars awake. The broadcast resets to talking heads reading scripts. Experts confirm natural fragmentation. The lie feels absurd after what you've just seen. Dee calls through video chat, face pale but eyes alight. "It blinked," she says before you can speak. "It literally blinked back at us." You nod, unable to stop smiling. She laughs, borderline hysterical. "We're in a call and response with a comet." You answer softly. "We were always the echo, Dee." The rest of the world erupts. Memes, prayers, markets, celebrations. Some people cry in public squares. Others hide in basements. One city projects the hexagon pattern onto skyscrapers. Another organizes a synchronized global blink event, everyone flashing house lights toward the sky every 47 seconds. Humanity blinks back. Historians still argue whether contact with the new world destroyed or remade the old one. You figure the analogy fits. Discovery is just another kind of collision. As dawn approaches, the comet's glow fades slightly, the fragments folding back into the main body. But the lunar markings remain, 6 bright hexagons etched into dust like footprints. NASA's official statement calls them optical illusions caused by albedo variance. You mutter, "Sure, illusions that persist in every wavelength." The next evening, amateur astronomers confirm the coordinates projected onto the moon point to an area in the South Pacific, an empty patch of ocean. Speculation ignites: landing site, message origin, mirror location. D texts, "They're choosing where to go." You respond, "Maybe where to arrive." Historians still debate whether fear or curiosity propels exploration. Tonight you know it's both. Adrenaline with a PhD. You stay awake until the comet sets beyond the horizon, the turquoise hue dissolving into dawn. Birds resume their songs cautiously, like musicians checking if the conductor's still there. You whisper, "See you soon." Then, for the briefest moment, the eastern sky flashes once, bright, deliberate, unmistakable. Not reflection, not coincidence. A wink. You laugh into your hands, half crying, half delirious. Around the world, others see it too. Social feeds overflow with the same 3 words. "It blinked back." You sit quietly afterward, listening to the hum fade. Whatever happens next, panic, faith, denial, you realize the conversation has already begun. Humanity spoke in noise, and the universe answered in light. You close your laptop, press your palm against the cold window pane, and feel the faint warmth of sunrise mixing with that last turquoise afterglow. You whisper, "We see you too." You tell yourself you're not going to watch it live this time. You've had enough cosmic cliffhangers, enough all-nighters and blue light headaches. Yet when the first emergency alert buzzes across your phone, unidentified atmospheric entry observed over Central Pacific, you're already reaching for your laptop. Curiosity, that loyal parasite, always wins. The official feed begins with confusion, shaky satellite footage, a silver-green halo expanding like ink dropped in water. Commentators murmur about ionized debris. You know better. The coordinates match the ones burned into the moon. The visitor kept its promise. You drag the window across your screen until it fills your vision. Nightside Earth glows with turquoise veins, an aurora sprawled too far from the poles. Fishing vessels off Tahiti report light falling like snow. For an instant you imagine the Pacific breathing, its endless ribs of current illuminated from beneath. Historians still argue whether the first meteor that frightened ancient peoples birthed mythology or meteorology. You decide it was both, fear dressed as science. Tonight you understand their confusion intimately. The camera zooms. The object isn't burning up, it's breaking. A luminous mist fans behind it, diffusing into concentric rings, shock waves of light rather than sound. Someone on the broadcast mutters, "No sonic boom." Another whispers, "It's soft." You shiver. The comet is landing the way a feather might fall if the air loved it back. Every network scrambles for coverage. You hop between feeds. A Hawaiian weather satellite catching hexagonal reflections on the ocean. An Australian observatory posting heat maps of precise engineered cooling. The sea beneath the descent point dims rather than brightens, temperature dropping 5 degrees in minutes, as if the visitor is drinking energy, not spending it. Historians still argue whether the 1908 Tunguska event was a meteor, a comet, or something stranger. The difference is mostly politeness. Destruction and wonder often wear the same suit. But this is choreography. You start a private call with Dee. Her face appears grainy but radiant. "They're slowing to suborbital velocity," she says before you can ask. "Not impact. Arrival." Her voice cracks on the last word. The live feed cuts to infrared. The comet has unfurled again, 6 petals spanning kilometers wide. Between them glows a hollow space, perfect circle, perfectly still. Ocean vapor condenses around it, forming a spiral storm that refuses to spin out. Weather systems freeze mid-flow as if time itself pauses for the spectacle. The commentators lose composure. One whispers prayers. Another insists it's atmospheric interference. You watch quietly, heart pacing that familiar 47-second rhythm. Suddenly the petals tilt. A beam, not bright but deep, a column of visible silence, reaches from the core to the sea. The water beneath fluoresces, blooming turquoise rings that widen outward like ripples from a dropped idea. Ships report their instruments dead, compasses delirious. Historians of exploration recall Magellan describing the ocean's phosphorescent wakes that glowed under his ships. Maybe he saw something like this once, centuries early, and we forgot. The beam intensifies, carving a circular calm in the storm. Clouds part. Satellites lose telemetry exactly 47 seconds at a time. Then data resumes, cleaner than before, as if the visitor is editing the feed for clarity. You lean closer, whispering, "You're filming yourself for us." Dee laughs nervously. They know their angles. From the dark horizon, fleets of aircraft scramble, military, scientific, suicidal. The cameras tracking them capture something surreal. As each jet approaches the beam, its radar flickers with hexagonal interference patterns, then clears. Pilots report no turbulence, no resistance, only an overwhelming sense of calm. Like flying through music, one says before the signal cuts. You think about how communication evolves. First sound, then symbols, now geometry embodied. Historians still argue whether Pythagoras believed numbers ruled the cosmos or merely described it. Tonight, numbers perform. The world below loses patience. Governments issue conflicting statements. Controlled descent, planned demonstration, unconfirmed re-entry. Social feeds dissolve into prophecy. Some users live stream seaside vigils, others stockpile canned food. You watch both, equally fascinated. Panic and reverence now share the same Wi-Fi. Then through the main broadcast, a voice breaks. Unfiltered, unscripted, a pilot's live channel accidentally open. "I'm seeing mirrors, 6 of them, each the size of a city." His breathing quickens. "They're not reflecting, they're showing things." Earth, but from above the line dies. You replay his words in your head. Showing, not reflecting. You imagine the petals acting as lenses, capturing the planet's surface and returning the image in real time, a cosmic mirror angled for our self-inspection. Historians still debate whether the invention of photography changed truth or merely its posture. Maybe tonight's mirror is doing both. For a full hour, the structure hovers motionless above the Pacific. Ocean currents circle obediently. Clouds edge around its perimeter like supplicants. Then, gradually, the beam widens until half the hemisphere glows turquoise. The light isn't harsh. It feels medicinal, like the world's largest nightlight switched on for anxious children. Seismic monitors register a low resonance, 47 hertz again, propagating through ocean crust. Scientists claim it's harmless, though the data graphs resemble cardiograms more than earthquakes. You wonder whether the planet itself is responding. Dee whispers through static, "I think it's tuning us." You almost laugh, but the idea feels plausible. The hum vibrates floorboards, glasses, bones. You step onto the balcony, where neighbors stand barefoot and silent. No one speaks. Every heartbeat seems to sync with that slow, colossal pulse. Then the beam narrows again, drawing energy back toward the sky. The ocean beneath reveals something unthinkable. A vast ring of hexagonal patterns glowing on the water's surface, stretching hundreds of kilometers across like a luminous crop circle for Poseidon. The formation matches the lattice seen in Webb's images months ago. You murmur, "It brought its blueprint home." Historians still argue whether Stonehenge was calendar, temple, or landing pad. Maybe ancient builders just tried to imitate this. The light retracts completely, and for one terrifying moment, darkness swallows everything. You hold your breath. Then the central void of the structure flashes once, white, clean, final. The shock wave is silent but tangible. Wind races inland, rattling windows worldwide. When the feed stabilizes, the visitor is gone. Only the faint turquoise ring on the ocean remains, fading like breath on glass. Headlines explode instantly. Comet disintegrates in upper atmosphere. Mission successful. Phenomenon resolved. You snort. Humanity's first reflex after awe is always paperwork. Dee calls again, eyes wet. "They didn't leave," she says. "They merged. Look at sea level sensors." She shares a chart, a global average rise of exactly 4.7 millimeters, synchronous, everywhere. Not tidal, not natural, as if a layer of the visitor dissolved into the planet's hydrosphere. Historians still argue whether meteorites seeded life on Earth. You wonder whether this is the sequel, life seeding itself back. You spend the next hours scrolling between relief and disbelief. Governments declare stability restored. The turquoise haze around daylight fades, leaving skies painfully normal. But if you close your eyes, the hum persists, subtle, soothing, like ocean in a seashell. You place a hand over your heart and feel it matching the beat. The world starts inventing new words. News anchors test phrases like event horizon of understanding and the Pacific bloom. Artists paint turquoise spirals. Songwriters record entire albums in 47 beat cycles. Schools plan Reflection Day. You smile, thinking of how easily humanity trades fear for nostalgia once the light show ends. Historians still argue whether enlightenment is event or process. You're beginning to suspect its rhythm. Night falls again. The sea has returned to black, but satellites detect persistent bioluminescence along the ring, tiny organisms fluorescing in perfect hexagons. The pattern spreads slowly, mile by mile, as if the ocean learned a new alphabet. Marine biologists call it unprecedented. You whisper, inheritance. Before sleeping, you open your notebook, adding one final entry, comet dissolved into ocean. Definition, completed. You underline it, close the cover, and for the first time in months, the hum soothes you instead of keeping you awake. Outside, the Pacific breathes, glowing faintly, as if the planet itself has begun to dream. Morning arrives without headlines for the first time in months. No urgent pings, no flashing banners, no emergency briefings. Just sunlight, ordinary, golden, almost suspicious in its calm. You open the window expecting turquoise haze, but the air is clear, the sky textbook blue. The world has returned to default settings, or at least it wants you to believe that. Somewhere below, the Pacific Ring still glows faintly, a halo on the planet's underbelly. But news anchors call it phytoplankton bloom. They say the ocean's photosynthetic cycles simply overachieved. You sip coffee and smile into the lie. The hum hasn't left. It's just quieter, folded under the day like bass beneath melody. You feel it when the refrigerator vibrates, when the neighbor's dog pauses mid-bark as if listening. You can't unhear 47 hertz anymore. It's become the metronome of existence, a reminder that silence is never total. Historians still argue whether the end of Apollo missions marked a retreat from wonder or its domestication. Maybe humanity simply learned to normalize miracles. You scroll through feeds cautiously, like checking a wound you know still aches. Memes remain, of course. People editing the comet into vacation photos, posting "wish you were here" with turquoise filters. A fringe group claims the ocean glow cures anxiety. Influencers sell bottled seawater labeled a TLAS essence. You want to be angry, but mostly you're amused. The sacred never stays unmonetized for long. Dee messages you a photo from her lab, a petri dish of bioluminescent plankton pulsing in six-pointed symmetry. They copied the lattice, she writes. Even under microscope, rhythm holds. You stare at the GIF she attaches, tiny organisms flashing every 47 seconds like microscopic heartbeat monitors. You type back, maybe that's what inheritance looks like. Historians still debate whether panspermia is myth or mechanism, whether life's seeds drift freely between worlds. You think of the comet dissolving into the ocean, leaving behind light as its only proof of arrival, and wonder if Earth just got repollinated with curiosity itself. For a week, the world pretends to move on. Stock markets recover, schools reopen, reality resumes its scheduled programming. Yet beneath that normalcy runs a gentle weirdness. Migratory birds change routes, following the faint turquoise shimmer at night. Whales breach along the ring's perimeter and stay there, singing in intervals matching the 47 hertz hum. Satellite dishes catch faint electromagnetic whispers. Not messages exactly, just patterned patience. The planet hums like a tuning fork, finally struck correctly. You start receiving emails from strangers who somehow found your old analyses. Do you think it's still alive? One asks. Another, if it's in the water, does that make Earth part of it now? You stare at that question longer than you mean to. The logical answer is no, but logic feels prehistoric these days. Historians still argue whether Copernicus truly dethroned humanity from the cosmic center or merely upgraded our address. Maybe 3I/ATLAS did both again, moved us from observer to participant. At night, you walk to the shore. The beach looks ordinary until your eyes adjust. Faint turquoise veins shimmer under the waves like luminous handwriting erased by each tide. You kneel, scoop a handful of seawater, and it glows briefly between your fingers before fading. The glow doesn't burn. It feels like a pulse returning a greeting. You whisper, "Still there," and the foam answers with a fizz that sounds suspiciously like laughter. Back home, you try sleeping, but dreams arrive bright and geometric. You're inside the lattice again, walking corridors of liquid light. The walls breathe with the same rhythm as the sea. A voice, not sound, but organized warmth, murmurs, "Symbiosis achieved." You wake, gasping, half in awe, half in comprehension. The visitor didn't leave anything behind. It became something shared. Historians still debate whether language began as mimicry or magic. Maybe this was both. We imitated the cosmos until it started imitating us back. Weeks pass. Governments issue final reports stamped closed case. They call it an atmospheric and biological phenomenon consistent with natural parameters. The press conference lasts exactly 47 minutes. You laugh aloud when you notice. The universe has a sense of comedic timing. Dee visits for the first time since the descent. She looks different. Not tired exactly, more decelerated. Over tea, she says quietly, "The ocean's composition changed. Trace isotopes that don't belong here. They resonate at frequencies matching neural oscillations. When people stand near the shore, their EEGs sync you blink. So we're in tune?" She shrugs. "Maybe we're part of the instrument now." You step outside together that evening. Streetlights flicker faintly turquoise, then settle back to yellow. Somewhere deep in the city, a chorus of power lines hums the same subsonic note. Dee closes her eyes. "Do you feel that?" You nod. It's like the planet breathing through concrete. Historians still argue whether enlightenment happens collectively or one skull at a time. You suspect it's happening through infrastructure. Later on the news, a weather anchor jokes that hurricanes are behaving unusually politely, dissolving early instead of intensifying. Ocean currents have stabilized, global temperatures dipped a degree, wind patterns softened. The world, it seems, exhaled tension. Comment sections call it coincidence. You call it assimilation. You write in your notebook, "When a comet teaches you to breathe, climate becomes conversation." One afternoon, you walk through a city park. Children chase bubbles that glow faintly blue in sunlight. Street musicians unconsciously play in 47 beat loops. No one notices. The adjustment feels natural, like culture updating firmware. Somewhere, an old man feeds pigeons that shimmer faintly under ultraviolet light, feathers catching residual fluorescence. You realize that normal has been redefined, invisibly and completely. Historians still debate whether Renaissance art shifted perspective because of glass lenses or divine mood. You suspect small changes in light always rewrite reality. You keep corresponding with Dee. She sends you daily sensor readings, ocean pH stable, plankton thriving, electromagnetic background oscillating predictably. "The hum's permanent," she writes. "Planetary heart monitor active." You reply, "We should listen for arrhythmia." She types back a smiley shaped like a hexagon. At night, storms have begun forming along the turquoise ring, but dissipate into rainbows instead of lightning. You watch footage of one, mesmerized by clouds folding in perfect spirals, each rotation punctuated by faint flashes of green. The rain that follows carries microscopic hexagonal crystals, not salt, not ice, something new. Scientists name them atlasones before the committee bans the term for lack of classification. You laugh softly. always allergic to poetry. Historians still argue whether naming creation is act of dominance or gratitude. You decide tonight that it's both. Sleep returns gradually. When you finally drift off, you dream in sonar, pulses expanding through water, bouncing between continents, mapping the curve of the world. Each echo returns a single word: present. You wake at sunrise feeling lighter, as if gravity has agreed to partial custody. You brew coffee, step onto the balcony, and realize the turquoise glow has faded to a paler hue. Less a signal now, more a memory. Maybe the world doesn't need to shout anymore. Maybe the message completed itself. Historians will one day argue whether this was visitation, awakening, or accident. Museums will display fragments of ocean sediment glowing faintly in dark rooms. School children will memorize the date and yawn. Yet some nights, when the tide aligns and wind hushes, you'll still hear it. That faint, patient hum, reminding everything it's connected. You write one last note in your notebook, the final line under months of disbelief and awe. The comet taught us to listen until we heard ourselves. You close the book and place it by the window where morning light can find it. Outside, the ocean turns silver again, ordinary at last, and in the quiet between waves you almost miss the faintest shimmer. 6 points of turquoise rising and fading beneath the surface, blinking once like a satisfied eye.